We need to know when we can start. Are you live?
Yes, I've started.
Okay.
And this is the first one, right?
Yeah, but yeah, probably.
Yeah, this is the demo stage.
So we quickly want to start. So grab a seat, grab something to drink, that come to the front. Here are still some space. Give us a couple of seconds. Okay, let's just get started. So we welcome everyone here in the room and also on the different platforms, multi-stream. And my name is Torsten.
Hi, my name is Martina. We're both from Microsoft. We're both both market managers for developers in Jersey. So we try to convince you that we have the right knowledge to successful new roles. We will really more. And that's also why we created
Exactly. Yeah, we're really excited that we can start today in our brand new Microsoft Reactor Popup in Berlin. You might know that there are several other reactors all over the world, and now we can really be proud that we have something in Berlin itself. It is a pilot though, so we started like we do today, and then we see. It's not a normal reactor, so we don't have it open every day. You can join whenever you want. But we will start with a lot of community events, with a lot of meetups, and so today is the first meetup. But before we dig deeper into the agenda of today, we have to go through the code of conduct. Do you want to read it?
So, as you know, our mission is to empower every person, everyone based on understanding more. And this, of course, also includes our events. So we seek to create a respectful and friendly environment for everyone here and also in the stream. So please be kind to each other in the chat and also here on site. We do not tolerate any behavior that is disrespectful, and we have the right to remove you from the space or even from the streets. All right, so maybe just to kick it off, who is a developer? I expected that. Who is from Berlin? And who has joined the Reactor event before? Okay. Right. And this is your first Microsoft. Nice. Cool.
Okay, then let's have a look at our agenda. I'm not 100% sure we can display it now, but we will start in a couple of minutes with Clemens, and he will give a talk. Oh, there it is, right. Session 1, reducing vendor lock-in for cloud AWS. And I think we have something like 5 more minutes. And then we continue with, do we have another slide for the other sessions? We will introduce them later. Okay. So,
but you come to this, if you're looking for the restrooms, they are through the door to the right. And also here, you saw the link that will also have some pizza there, and at 6:30, so basically when the second session ends. Just so you know, when you expect anything else.
actually, not. Just one thing. So we are planning to host at least 2 or 3 events per month, starting right now, basically. And whenever you think there is something that you want to contribute, or maybe you also want to host a meetup or something, then just reach out to us and we can actually talk about that. So we can like the story.
I thought it was starting at 5:30.
Yeah, of course. Also, if you don't want to host the whole event, but just want to contribute to the session.
It's all right.
And with that, I think we can do some more text setup. We start at 5. Thanks, and have a lot of fun today.
Hi, hey there. No, 5:10. Oh, so 5. Yeah.
Okay, so now the idea is to add. Don't worry, you guys did well.
Yeah.
Yeah, I could see the word. A little nervous. or
Yeah,
something. I was like,
well,
why are you nervous? It's such a chill crowd. No problem. I was just telling her, don't worry, you guys were like super chill. Like, and also it's a chill crowd, so
Yeah.
don't worry about it. I can add this to the stream now. This is Clemens.
So, yeah. Yeah, I mean, it's the
Because
title
I can
slide.
see his.
Yeah.
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 So I can just
Yeah,
add this. Perfect. Also, we're live. Everything's fine.
Okay,
we'll
monitor the
stream chat. I think I told Chris also about it.
Yeah.
So we actually don't know. Maybe it was just a matter of like plugging everything.
Martina, kannst du Witz erzählen, während wir warten? Weil das kann ich im Bereich.
Okay, so.
Okay, and you know how to put the other thing then around, right?
I
The other scene.
I think that is with the OBS thing, but then that wasn't working earlier, so I don't know if I should take the chance right now.
Yeah.
Let me see. Try this. But isn't this too pixelated or?
It should be there
It's a
already.
bit, right?
Yeah, it is a little pixelated, this
It
one.
looks like,
Yeah.
What is that? But that doesn't matter. That doesn't matter. It's
That doesn't
very
matter.
small and
I will
Okay.
keep it to the right.
Okay.
You know, I mean, if
You have to see what it is on the other thing.
yeah, that's better. Yeah.
It's just the pixelation that I'm worried about, but anyway, let's just go here and we can try
Only if
for
it looks
this.
like that here is
Yes.
it a problem. Why does it look like that? That's weird.
but it doesn't matter. It's just small there.
That's fine?
Yeah.
Is this okay? Okay, cool.
Why is he not centered? I mean, he's cropped, right?
Let's do that. Yeah, we can do this right
Yeah,
away.
yeah, better. Yeah.
Yeah? Yeah. I think
Then
it's,
we can still see maybe move like a meter or
Yeah.
so. Thanks so much. Sorry,
No,
that
no
was quite
worries.
stressful.
no worries, no worries. It's fine.
Benazir, do you quickly want to talk just 1 minute about December 8th that we host the next one, and then we can do December 15th?
Yeah.
We are also planning to, along with Torsten and Martina, we're also taking steps. We have also merged the Kubernetes and Azure Berlin pages and formed one Kubernetes. And our idea is also start posting those regiments on December onwards. Our first one was December 8th. The media pages all I can share details about data, we'll visit the Twitter page or the LinkedIn page, and also more details about the writing posts. So yeah, we hope you guys come and support us in that, and it's for you, for anyone else in the community, and for us to have a space that we can get together and have pizzas and beers later and also people wanted. Trust me, it was some effort today, Microsoft also really is in terms of like the markets and all that. We're very happy to do it, and we're very happy to Microsoft supporting us with all of this. And very excited for Microsoft Reactor Berlin. Very excited for how we at Microsoft can do it and how we can go forward with it and how to support this year. So yeah, seriously, there will be more after that, of course, and I'm sure the person will be getting more about this.
We will tell you, now let's really get started and we have to discover the power of the
They haven't finished.
The problem is, this speaker is, there's a white noise, a loud noise.
Yeah.
You're finished with this mic now? The blue with the mic? Yeah, I think there's something.
So I understand
We didn't.
But now it's also gone. It was just on the mic.
You can see the live
Nobody's watching, but
No, I think it's still listening.
There's two people.
this is just my LinkedIn. Is it my LinkedIn? So that was just my thing. We have to check the Reactor page, the reactor.microsoft.com, and check how many people are there.
So we talk about what is web search for yeah, of course, feel free to interrupt me at any point. I really love the questions and don't see the chat button. If you have a question in the chat, I hope that somebody's watching that. Maybe. But yeah, feel free to write a chat, questions into the chat. Just raise your hand, hit noise, you can shout. Press the voting and repeat it, so everyone's curious and so first things first. So what I want to do is not just platform for example, let's say it can also be Twitter, for example, where you have social media platform, you want to use somewhere else, you don't want to use it for any friends, there's a huge count in moving to another platform. The other thing is feeling on this cost of moving from one place to another and moving something or having to invest a lot of work and a lot of money in changing things and changing things forward. So if the audience is really interested in
We have two things.
maybe someone wants to sell from the previous contract is not doing the same match for example. Not maybe it's better like this. Can use my like this. That's better to hear. I hope our screen is better now.
Yep.
Okay, so I was asking examples of vendor login, but I of course you can few. So
So did you put your headphones on and listen to this?
That's the thing. I've been trying to connect to you, but it just doesn't show.
It seems like the audio quality in the streams.
That's what we're checking. That's what we just heard. Okay, you need to test this. You shouldn't have to do any of that. You should be able to open that up, put it close.
Yeah, but it's not catching it. That's the thing.
Yeah, just press the button for some time. There it is. There it is.
Yeah, but it's not been catching it.
Wait a second. Wait a second. So why is it not showing any?
Yeah.
Yeah, go to the preferences.
No.
Yeah.
Where is it?
Yeah, there. Okay. That's what, this is the problem.
Pressing the button. It's on the back. Yeah, no.
It should catch it now.
Should.
And yeah, of course, changing your software might also be something if you use Microsoft Word, for example. In the past,
I don't know what's happening to your thing.
I don't either, that's what I'm like.
We have headphones here.
So I found some random work on the internet to do it's something that keeps them on your platform, but it doesn't really add any value for the customer. And I would argue that it is important that also for bigger companies. And if you want to be unique, if you really have a feature nobody else has, I would argue that it's also a type of technology that they do not have. But I would call that kind of positive vendor in the way that people really want to stay on the platform because they have something that they really want to don't want to miss on their platform. Right? Also, vendor lock-in might work for custom growth. So if you're a smaller company, you hear, hey, what's the software?
Oh, I know why. You've got the camera feed. You've got to change this to the microphone. You have to do mic in.
Settings.
Audio.
Oh my God.
Also, nowadays, especially the Azure platform and Microsoft has a subscription-based model as well. And there, it's really important that your customer is successful on that platform. Because if your customer is successful, you are successful. The more successful your customer is, the more they will use your platform. If they are not successful because they are locked into your platform and you don't give them any additional features, they will not grow their business. And yeah, maybe your customer is not able to do your next big thing that you are developing right now because you've locked them into something old and they are never able to move away from that. Okay, so second big topic of today is where to look for vendor lock-in. So I'll show you a sample architecture. I've abstracted it and reduced the complexity as much as possible. So this is the sample that I'm talking about, that I'm working on right now. Cannot disclose what the customer is, but it's, let's say it's they sell IoT devices that come attached to 4 wheels and usually have a motor. So it's in a specific industry and they have a huge cloud native application that is built largely on a function-based, event-driven programming model, let's say. So they have an API management in the front, so they have a managed API from their platform vendor, and end customers use that these APIs from their mobile devices largely to interact with the software and with their IoT device. They have an authentication function that makes sure that the user is authorized and every request against that API is authorized. They have a backend or various backend services running on functions that interact with databases, with message queues, and then maybe do batch processing or event-based further processing. And they have a large integration with an IoT-based platform from a cloud hosting vendor at that point, right? So they are using core IoT functionality from a platform vendor, and it's really difficult to move away from that because you would have to update all the IoT devices, change the root of trust, and so on and so forth. Nevertheless, the customer decided that they want to move that platform and they want to be a little bit more vendor independent, and they want to move that software gradually over to a container-based environment. I'll talk about the target architecture where they want to move to in a little bit, but let's take a look first at these 5 different points that I've marked here that are specific areas for vendor lock-in that we've found and detected and analyzed, and we are trying to solve some of these problem areas in the future, or are actively working on that right now. So number 1, the API. So they're using this vendor-specific API management that gives them a lot of additional functionality. So there's access control with authorizer functions. They have request validation, schema validation, checking that every request has a certain structure. They do data transformation. They are doing optimization, caching, and protecting of their API-based application, right? So they have throttling mechanisms. They have a web application firewall, and this vendor-specific API management comes with a lot of services, but also for the developers, it's kind of hard. They cannot run the entire set of application on their local device because there's a large integration with this vendor-specific API management software in front. So this is one of the bigger pain points of when moving away from there. The second thing that we found is that the source code itself, so in the functions that they wrote, they have direct implementation of vendor APIs, and they also have direct dependencies on vendor SDKs. So when I talk about vendor APIs, I usually mean the method signature that they have to implement when they are writing event-based code. So there's an HTTP request coming to the API. That HTTP request triggers some function in their backend, and they directly implemented this API, and the business logic is right there, directly implemented into this into that method signature that the cloud platform requires you to implement. And then downstream, they are using direct vendor SDKs again to write to things like cloud databases, DynamoDB, Cosmos DB, something like that. And also to message queues, platform-specific message queues with vendor SDKs again, with no abstraction in between that. And the missing abstraction to the downstream services is really something that makes it really hard to change the software and to move away to different services. And yeah, on the target platform, so they want to move to Kubernetes, and some of these features are not just built in, like, so their schema validation part, for example, doesn't really make sense in a lot of the ingress controllers that Kubernetes provides. All right, so third part, the database service. So they already collected a large amount of data in their databases, and they are using a proprietary database solution, and they have a lot of data that they might eventually want to transfer, but it's an amount of data that might imply a huge amount of transfer cost for the data. And the question of downtime is also something that they cannot have. They cannot have any downtime when they move their application, and they might want to do a live migration in that case. Area 4 is about tooling, deployment, and monitoring. So they also wrote their own tooling to to have a workflow automation for CI/CD. So they are actually very advanced in their I would say in their cloud native journey. They have a lot of tooling in place. Some of them is self-written, and they have automated most parts of automation of deploying the application, and also of creating the infrastructure that accompanies the application. So they have a lot of automation, they have a lot of monitoring and alerting built in, and they have their own specific ways of deploying, and they also use vendor-specific infrastructure as code. So they don't use Terraform. They use I think CloudFormation in that case for AWS in that example, and they have a lot of knowledge for one specific platform vendor, and changing the tooling might also be a difficult task. And lastly, platform services. So they have definitely quite a few features that they use. They use IoT Core, they use message queues and buses, and they use platform events for scaling signals, for monitoring, for cost alerts. All of these things also need to be taken into account when moving your entire application over. And update management, maintenance, also a big topic, and then identity and access management. Also, especially if you are in a hybrid mode where you're running on 2 cloud hosting platforms, can be really, really tricky to get that right and not overcomplicate things and leak access credentials and leave them everywhere and copy them over from A to B, stuff like that. Things that you really want to avoid. Usually you want to use the platform providers identity management so that you have integrated roles and don't share access credentials between the services. So I want to go back one slide so that you can see one more time the overall architecture. These are like the different problem areas, and I should have brought that slide maybe here again. But in summary, problematic are use of vendor SDKs, use of vendor-specific services, complex cloud infrastructure, CI/CD pipelines and integration, and the big knowledge gap. So to really get your application up and running in a production environment again, requires you to really know the intricacies of the platform provider, and you need to skill up and you need to test and try and maybe do some load testing and really start learning what the platform can do. These are the problem areas that we've identified. Any additional insights? So this would be a good place to maybe ask a question or add another insight that you might have from your, oh, 2 hands raised. Left first.
Yeah. Question about the pipeline.
Yes.
You said they wrote their tools themselves.
Yes. Mm-hmm.
This is the point why the system of it and this project, or is it general problem? You have CI/CD pipelines, they are often a point for vendor.
Yeah, so I would argue if you invested a lot of amount of time. Oh yes, sorry. Thanks for reminding me. So the question was, is it a problem that they wrote their own tooling for CI/CD, or is, well, hopefully I get your question right? So is that the point of the problem, or is CI/CD and pipelining a general problem when about vendor lock-in, right? So I would argue that it's a general problem because usually the pipelines itself, at least you need to rewrite a little bit of that. You need to rewrite the authorization for the pipeline. You need to maybe reorder things a little bit. Maybe you have a different deployment target. So we had the function-based environment that was a deployment target. Now we want to maybe move to containers. So things need to change. And since it's just about the cost of moving your application, I would argue that it's always a little bit of vendor lock-in, right? Or it's a little bit of lock-in, extra work that you have to do. So there might be work that you have to do anyways when you move from one platform to another, but maybe, yeah, you have to discard some of the tooling. Maybe you have to rewrite things. Maybe you want to even use existing tooling, open source tooling, or generally available tools that are a little bit easier then. And we had a second question over there to the right. Oh, yeah. Yeah. So the question is the type or the choice of programming language a problem when talking about vendor login? So it might be. So if you have a function-based environment and there's no runtime for that other programming or for your programming language on the other platform, or that doesn't work really well in the other platform, that might be a source of vendor lock-in as well. In this case, we are moving from a very platform-specific tool to Kubernetes, and maybe I can explain a little bit why they picked that platform. But since they are able to containerize their programming language, although like Java is not super easy to containerize, maybe they have to rework a little bit, but they're using Java in that sample and a little bit of Python and a little bit of Node.js. All these programming languages can be containerized, so it's not a big deal, I would say. And it's by far, I would say, one of the areas that have fewer problems and fewer areas of rework, really, than others, maybe. Okay, thanks for, there's more questions. And first the audience, Ozzy, sorry. We have a question in the back. Yes, definitely. And that is, if they have to spend that amount of money, so their contracts can have that. So for example, or you like platforms like Netflix also have kind of vendor lock-in, right? So there might be a series that you want to watch and it's only there. And so there's different, you might argue that is maybe a feature lock-in. But yeah, the contractual obligations might be something, or that you get a bigger discount on one platform and a smaller discount on the other platform. But that's usually a business problem. And for me today, for my talk, not so much in that scope, because usually people start to make competitive offers and hey, if you move over, we'll give you a bigger discount than the competitor, right? So, and then they're competing against that. So that's, I think, the discount. Once you've signed the contract, for sure, then it's a lock-in. And Ozzy, you had a question.
I just want to say, maybe not language, but framework.
Framework can definitely be. So SDKs, especially if you are building on top of vendor-specific SDKs, really a point of lock-in. So next section would be talking about gradually reducing the login, right? So the problem that they have is also that they are running this application and they have like 700,000 IoT devices running on their platform already. So they're not able to just, hey, let's rebuild things and like, at day X, we switch everything over and then we are done. That's not going to work. So they want to gradually reduce the vendor login until they can deploy the same source code to both platforms, explore and test the new implementation, the new platform, and then move over gradually and service by service. They have a lot of different microservices, I would say, independent services that they are running. Yeah, their plan is to do that step by step, service by service, and maybe, yeah, some first, others later that are more complex. You did not have a question, Ozzy. You had a comment, right? Okay, yeah, okay. Anybody else? There's one more hand in the back. I cannot really see you. Yeah. Yeah, so if you use a vendor-specific logging platform, it might be a source of login. So for example, also on Microsoft's platform, right? So if you're using Azure monitoring, they have this vendor-specific query language, Custo, for the monitor workspace, and you might need to write some logging queries. You might have to redesign dashboards or something like that. So that is definitely also point of vendor login. Yeah. Okay. I don't see any more hands right now. I don't know if there's questions on the chat. I've not heard any. So I'm sorry if you wrote a question on the chat. Maybe people will tell me, maybe not. There is a question? Yeah, we are checking. Great. Okay, so gradually reducing login. So before we really dive into that, let's take a look at the target picture, right? So here's a picture of the target architecture that customer and architects and advisors have agreed on. So the good thing is that the new on the new platform, they already have a Kubernetes cluster and a managed environment, an extra team that really manages their Kubernetes environment. So each team that migrates a service can actually request a namespace or multiple namespace in different Kubernetes clusters. They have a whole tooling for that. Together with that namespace, you also get an Azure resource group where you can deploy your own resources that you might need. And they've set up all the networking infrastructure and the baseline components and the infrastructure components in the cluster, the security baseline. They have different levels of security for dev and pre-production and production environments. So they spend a lot of effort in creating a great Kubernetes platform, great Kubernetes environment that is managed for the development teams. So they don't have to do the updates on the Kubernetes cluster, things that Ozzy will be talking about, I think, in a few minutes. So they have this platform, and so this is kind of the target architecture. They are already with their source code in Git or GitHub. Yeah, I think even GitHub, and they will be using different components that I'll explain in the next few minutes in a little bit more detail. So they have an ingress controller already set up in their environment. They have the option to deploy their own containers and pods into that environment. So what they will be doing is they will containerize the functions and run them inside a container, and maybe have a sidecar container that does the authorization for the API layer. They will implement their own API in that service itself and move away from a vendor-specific API management. So they will write something that is really portable, that you can also run and execute on your local machine. And in terms of tooling, they will use something called GitOps. So they will kind of apply everything that is inside their Git repository onto the cluster and onto their namespace. Everybody can set that up the way they like. Follow different branches. They will use something that is called a service operator or Azure service operator, or some people might know tools like Crossplane. So they want to extend the Kubernetes cluster with custom resource definitions and custom service operators that can read those resource definitions and create automatically on a desired state basis resources in their specific resource group that is assigned to every team and every service, right? So there's different approaches. They can also bring their own infrastructure as code tools. So some teams try to explore a little bit working with Terraform as well, but largely they will probably use the service operator for the later teams that are onboarding a little bit later and are not the first and early adopters. So as soon as the resource definitions are in place, they will start using that. Okay, so first area of interest here on the left-hand side is how we reduced, I would call it the upstream login, right? So upstream login is everything that triggers your function, everything that triggers something in your backend logic. And for that, we decided to reduce a little bit, or I came up with this architecture diagram, or let's say a software design pattern diagram, where we don't have any dependencies of the business rules against the vendor-specific platform SDK anymore. So we came from a situation where the business logic and the business rules and your own source code really was tightly coupled to the AWS Lambda function handler. So the function handlers directly implemented the logic of the application, right? And what we did, or what we recommended to do, was to build a web API in front of that, use an open source framework that allows you to build easy APIs, and then map that to the business rules and maybe have a shared authorizer function, shared library, something that everybody can use and implement, and just as a middleware, add to that API. And then have a very, very slim function handler that maps every request in that API to the web API itself, right? So you wrap your web server kind of in the function handler, and then you run the web server in that container environment. And at the same time, so if you run in the container, your entry point would be the web API directly. If you run in a function environment, your specific function handler would wrap that and know the web API. But the web API and the business rules have no concern about the platform provider. And if there's a change in that SDK, or if I want to move to another platform, I don't have to change anything in my business rules. For the downstream dependencies, we've used a very, very similar pattern, right? So the idea is, again, to create an interface. It's also kind of a recommendation that many reference literature really mentions, is that if you write something into a database, you might want to abstract out that database, the concrete implementation of what kind of database you are using, right? So what we did is we created interfaces for the common operations, for creating new entries, for searching, indexing, looking up, updating, deleting records. And then we came up with a concrete implementation for that database access to the specific database, right? So what this allows us to do is the business rules only know the database interface, and then we can have different implementation for the database access and swapping that out depending on the configuration rather than a change in the source code. So this allows us to swap out the database access, and in the same way we did the same thing for all downstream dependencies. So for message queues or different kinds of message buses or process or inter-process communication as well. So and again, the idea is that there's no dependencies. The business rules do not depend on anything outside of our programming scope, right? So we have dependencies to these interfaces, but we control the interface, and that's fine. Do you raise your arm? No? We are not in school here. Okay, so this was the idea. What we actually came up with looked a little bit more beautiful and more real life, I would say. So it's too bad that you can not read this. So here it says AWS Lambda function handler that implements business rules and database access. So this was the original function that they had that did everything. So we really just wrote a small web API that managed all the part of the API management and mapped that to the different Lambda handler functions directly, and just re-implemented the authorizer function or moved the authorizer function also into the source code. This allowed us to bundle this part of the application here already into a Docker container. And then there's two different entry points. If you keep running on AWS Lambda, you directly execute the Lambda function handler. If you are running in a container on a local machine or in your Kubernetes cluster, then the entry point would be the web API that maps, then that wraps again in the vendor specific request object and passes that request object to the function handler. And downstream, we did exactly what we intended. We created an interface and started swapping out the different implementations here. All right. Too bad that I did not bring the slide for the architecture one more time here. Let me just jump here. So the second area that or the third area that we really took a look at was the tooling area. So for the GitOps and the service bus implementation. So let me just jump between slides. I'm sorry. Okay, so the cluster applies. So they have GitOps in place. So they have an Argo CD in every cluster that they're running, and they have a very simple method of setting up Argo CD, of bootstrapping Argo CD for multiple repositories for multiple environments. So they can just write an additional line in their YAML file in their repository, and that will create for the specific cluster that they want to target in different regions all over the world, creates a bootstrap configuration for their GitOps environment. So the cluster starts applying revisions of their cluster configuration automatically to their namespace, and that is a very, very easy and manageable way to handle multi-stage, multi-region, multi-cluster environments, right? So you can, for example, have a single branch, different clusters that follow this configuration. And if you make an update in your Git repository, eventually all those clusters will update themselves to a little bit of echo, will update themselves to the desired state, right? This reduces complexity in pipeline logic because you don't write any pipeline, you just set up the Argo CD initially, and then it pulls down every change. And it's for the developer, it's then just Git, right? You make a commit, maybe you have a pipeline, maybe you have a review process, but as soon as it is, I don't know, tagged maybe or in a specific branch, then it eventually will be live in your production environment. And one thing that is super neat also for these Kubernetes clusters in kind of restricted network environments is that there's no need to communicate directly with the control plane of the cluster. The cluster will communicate out of the virtual network, and the firewall, there's no hole punching in the firewall. The cluster needs to talk to your version control system, but the version control system or your pipeline runner never needs to have access to your cluster environment, which is also a very neat security feature, I would say. And then for the deployment of additional services, cloud services, and infrastructure that you need around that, they started implementing first their own service operators, but yeah, we are just switching that out right now to a more open source approach. So there is two tools that we are considering at the moment for the service operator part, and that is the Azure Service Operator for Kubernetes. That's the Microsoft product, I would say. It's an open sourced service operator for Kubernetes that allows you to create, I would say, 15 different Azure resources with their accompanying resource definitions and network integrations and stuff like that. The documentation is not super good, to be honest. It's largely auto-generated, and we are evaluating that against Crossplane as well. Crossplane has been in the market for, I don't know, 4 or 5 years already. So they have a huge set of custom resource definition and have a large library of resource definition to create almost any kind of cloud resource. Very, very similar to what Terraform might do as well. And the neat thing about the service operator is that you can apply the same model of deployment, the GitOps approach, to then also to the accompanying cloud infrastructure next to your Kubernetes cluster, right? So you might need a message queue in a specific configuration, database tables, whatever you need next to your cluster. You can then also use the cluster to create that resource, and all the synchronization and desired state processing that the Kubernetes cluster has also applies to your cloud resources. And it also comes with this desired state and drift detection, something that is usually not provided by regular infrastructure as code tools like Terraform or Bicep or ARM templates or CloudForm even I think CloudFormation nowadays also has a mode for drift detection, but I think you manually trigger or you run on a schedule, and Kubernetes already does that for you. All right. Any questions to this point? There's a hand raised. Yeah. With disaster recovery while running a service operator? Yeah, that's a good question. So, so you mean that when, wait, first repeat the question, sorry. So the question was, how do we deal with disaster recovery when the service operator runs, right? So if the service operator makes a change to my cloud environment and I do a breaking change, I delete the database on accident, something like that, right? Yeah. Yeah. Mm-hmm. Yeah. 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 Yeah, so you would not move. So let me rephrase what you just said. So the question was, hey, how do we deal with disaster recovery? Because the cluster basically knows what state has the state configuration that otherwise Terraform, for example, manages in its state file. In the case of a service operator, the service operator kind of holds the current state of the environment. And if you lose the cluster and you need to reprovision the cluster, you already lost all that configuration, right? So in the disaster recovery case, I think it's enough to probably just redeploy the YAML definitions into the new cluster that you provided. And if you are using the same namings, then the cluster should, or the service operator will detect that the resource is still there. So if you just lost the cluster, then it would pick up that the desired state is still equivalent to the existing state and will not touch the environment. Did that answer your question, or I think it works. I will try that. I will definitely try that. But I think more importantly, what happens if you have a breaking change while you roll out? That is also a very, very interesting thing, right? You accidentally deleted a database or something. How do you recover from that? So do you just a rollback to the latest commit might not work because you lost the data from the database, right? So also something that is really that we need to take into account. Yeah, thanks for the input. Great question. Anything else here? Not right now. Okay, cool. So that's not a question, right? Okay. All right. So last segment. How to prevent vendor lock-in. So in a perfect world, if you start a new project, you might directly apply software design patterns like the ones that I've just shared with you. Yeah, so my recommendation would be to always use interfaces or abstract classes to interact with your downstream services, right? So this allows you to use Liskow's substitution principle to have different implementations of the same interface, different implementations that can be swapped out, and your source code that relies on that interface will never know it's a different implementation, hopefully. Then you would also inject the concrete implementation to your controller. So you use software design patterns like inversion of control to set up everything once you bootstrap your service. I would recommend you to not implement directly against any vendor SDK, no matter what, no matter when. And I can also recommend the read of Clean Architecture by Roberts and Martin. Really, really good read. It has a lot of different tips on software, building software in general, and I would argue that most of these well-architected software principles also will guide you in writing applications that don't log into a specific platform or a specific database technology. And if you want to really use the latest and greatest and newest shit, of course, there is something for everybody, and also something that Microsoft provided to the CNCF organization. So there's I think it's still an incubator project right now. So Dapper, the distributed application runtime, uses the sidecar pattern in the Kubernetes environment to have basically these concrete implementations of the database connector or the message queue connector or the message invocation in a sidecar. So your application, you program against this generic interface of Dapper, and then you have different kinds of resources like databases, message queues, secret stores that you can access through a generalized API. And then you just configure the sidecar, and you might just add new implementations of that sidecar to implement vendor-specific services that provide you the same functionality, right? So this allows you to basically just reconfigure the sidecar and then just reuse or use a different database, use a different technology. Really, really neat idea, and also works with a lot of different programming languages. And if your programming language is not supported yet, you can just implement against the generic HTTP API and then have a socket connection there. Anybody, that's a good point to ask the audience if you have heard about Dapper and have actually maybe used it. So has anybody heard about it? Yeah, there's a few hands. And has anybody actually used it? Just 3, 4.5. Great. So cool. So any insights, any experience with that? Was it a pleasure? Was it a failure? Anybody want to share something? Yeah.
So far, I like it a lot. They're related to people still stuff missing, or like still in the data.
Yeah.
For example, database queries, it's still like, like basic stuff, but it's like still a lot of stuff that's missing. So then you end up with they're doing your own stuff with like this and that's
yeah. So I sum up your contribution there. So the contribution was that, it works quite well unless you want to do specific queries with your database implementation. I think that's something that is kind of out of scope sometimes for Dapper because they have a specific distributed application kind of access model to data and their data stores at the moment. But yeah, and then you start to implement in a very similar fashion as was just explained earlier in the talk. Against these interfaces that you yourself create, and that allows you still to swap out these different specific services. All right. I think that's kind of it. So Dapper, anything that I did not say about Dapper here, use case icon, it's a nice use. Yeah. So one thing that I did not mention is that the runtime overhead is very, very small for Dapper. So what happens, you run 2 containers in the same pod, sidecar container, and then they are scheduled on the same virtual machine, and then there's just a socket communication between the 2 services, so that adds less than a millisecond of delay. That might be if you're shaving off really like sub-millisecond times of your APIs or something, that might be a place to consider to remove Dapper then. But it's and it has a large support for different programming languages. Okay, so as a recap, we've discussed vendor lock-in for cloud-native applications. We've analyzed kind of where to look for vendor lock-in, what kind of services, what kind of parts of your application might be subject to vendor lock-in, where you will confront vendor lock-in if you really start moving away from one platform and move to another one. We've started to solve some of the problems that you encounter, definitely not all of them. Not all of them are solved, and a lot of them also have individual solutions, right? So depending on your software, there might be a very, very specific solution to that problem, or it might be really, really hard to solve, and you are really locked into that platform, and you are not going to move away from there. So then maybe you start to do something multi-cloud or discard the idea of moving. And then we discussed some software design patterns that might help. And we showed you the sidecar pattern for Kubernetes, and that is a cool baseline for building very, very powerful tools like, together with the operators, the and the sidecar pattern, you come up with really, really cool infrastructures and architectures, I would say. All right, so that's it for me. Thank you. Thanks for the questions. If you have... Yeah, thank you. So if you have any additional questions, you can still approach me. I'll be hanging around eating pizza and maybe drink one beer or so. And then you can also find me online on these handles. And can we share the slides? I don't know. We will somehow share the slides. So thank you.
Thanks, Clemens. Historical moment, right? The first session in the Berlin Reactor Pop-Up.
In Berlin.
So we have a lot of people standing in the back, and here is still some space. So I think, in theory, there should be at least space for 4 people on every bench. But if you squeeze a little bit, then it might be even space for 5 people. We are going to do a short break, and then it's Ozzy's turn. Kubernetes is a hammer, but sometimes you need a different tool, right? Something, exactly. So, in 4 minutes? So we have around like 4 or 5 minutes until we settle again then and start with the next session.
Hey, 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 test 1, 2, 3, 4. I am good. No, I closed that one a few minutes ago. But maybe people are joining via their Wi-Fi or something that creates echo. Because obviously mine is closed, so mine is mute. Yeah. It's microphone muted. Yeah, I think that creates the echo or something. Anyhow. I couldn't find the right place for that. Let's see. Yeah, I don't know. Maybe when I go this, it creates the echo. Yeah. Test 1, 2, 3, 4. Test. I think I should be keeping it like that, like Clemens. Test 1, 2, 3, 4. Take my note. That creates the echo. I'm ready. We can start if they are okay. My mic is working. The problem is we have an unknown echo coming from somewhere. No, it's close. Yeah. Mine.
You're not, you're on stream here, but your microphone is, yeah.
You see, I also disabled that one, you know. You see, it was that. My microphone is physically closed. I am physically muted. So I'm sure it's not this computer. maybe there's a computer connected from inside which has connected to StreamYard, or someone from the audience is connected to StreamYard. Okay, okay, let's get started.
Hello? Hello? It's not. Ah. Okay, everyone, with about 7 minutes of delay, we are going now to start the next session. So please, we still have 6, 7, 8 spare places here. So everyone in the back, if you're interested in... Hello! Simona! Simona!
They can't hear us.
We want to get started, so... Okay, we will have enough time for networking later, but now, you know, we want to hear Ozzy. So it's your turn now.
Okay, thank you, Torsten. So, welcome everyone. Can you hear me? I think we are good. We are good also in the stream. So, welcome to my session. First of all, thanks for joining us in this great event, opening of the Microsoft Reactor office in Berlin. And I am Özgur, and I'm going to tell you something about the Kubernetes, and it will be very interesting. Actually, it's a coincidence. Normally, we didn't arrange that with the Clemens, but I'm going to tell the opposite of what Clemens already told you today. I'm just joking, but you know, he encouraged you to use the Kubernetes basically to avoid vendor lock-in. But I want to approach this from a different perspective, and I want to tell you the story of the Kubernetes first. And I want to show you when it shines, but I also want to show you when it has some problems, so you should avoid that one. That will be basically the main topic of this presentation, and I hope this will not be the end of this. So I could explain this very well, and you will understand at the end what Kubernetes is and when you need to use that one. But first, let me quickly introduce myself. I'm Özgur Özturk, and as you heard, everybody calls me Ozzy at Microsoft. I'm a cloud solution architect working under the Global Partner Organization, which means I'm working with the partners in this German region to help them on their success. And basically, my main focus area is cloud-native application development. So this containerization, Kubernetes, DevOps, GitHub, all these poster childs are my playground on these days. And you can reach me over LinkedIn and also via Twitter, also via my blog website. So that being said, actually, let's get started with a question worth $44 billion. And this question is basically, how can you build a resilient platform that will survive even in case a billionaire buys your platform and fires half the employees? Does anybody have any answer to that question? Actually, my answer is the same. I don't know. Nobody knows on these days, and probably in a couple of months, we will learn the result and we will see how this experiment will end. But I am sure about one thing at the end. This conversation will have a story for the Kubernetes. Because Kubernetes is, at the moment, heavily used by the Twitter, as you know, and they are happy about that one because Kubernetes solves lots of problems when you operate on that scale, on Twitter scale. You know, it is a distributed application and they need to run this for all over the world. It's not just for Germany, it's not just for the United States, so they need to build a huge infrastructure to be able to serve their customers. So, oh, sorry. Beamer got off, 1 second. Sure, okay. So, long story short, Twitter is kind of part of this story, but we don't know the results yet. So it will be a good story or it will be a bad story. We will figure this out. And actually, why I started with that one, why I mentioned the Twitter and what I trying to say at the moment, the story of the Kubernetes, the main topic of this session is that one. Why Twitter is using Kubernetes? Why everybody is loving Kubernetes? For example, I built my own career on top of the Kubernetes and containerization. During the last 4 years, I have been working very heavily with Kubernetes, but at the end, I am creating a session about why you don't need to use Kubernetes or why when it doesn't fit to the picture. So first of all, I want to explain why everybody loves Kubernetes and why it's a kind of a poster child on these days and which kind of problems does it solve. Because that is the important part. Most of the Kubernetes discussion that I involve with the customers, partners, and that kind of places, that kind of engagements, I see that they really want to use Kubernetes because the main reason of that one, everybody uses Kubernetes. They don't know the benefits, they don't know which problem is solved by the Kubernetes or what they can get from the Kubernetes. They just want to use that one because everybody uses that one. So now I want to show you which problems Kubernetes can solve very well and which problems it cannot solve, so we need to avoid that. So to be able to do that, let's create a scenario and let's imagine that we are part of a small development team, okay? And our company said that we want to build an e-commerce application and that task has been assigned to my team. Like 4 developers or 5 developers, we started to work on this e-commerce application for our company. So 1 second. And as you understand, we are a small team, we are part of a small team, so we don't have lots of resources. For that reason, we started with very traditional 3-tier application architecture for this application. A React front-end, a .NET backend. We have a database, but we want to split the process up, so we put a Redis cache between the backend and the database. So it is very primitive, but it is we are just 4 developers. We don't have any resources yet to build this big microservice architectures or a fancy architecture. So this is more than enough for us. So everything is okay. We start to write this application. We built this application on our computers and everything is working fine. We are nearly ready for the version 1. So what we do, basically, we containerize these applications on these days because containerization gives us lots of benefits. If it works on your machine, it will work on the production. That is big benefit of using the containerization. Not just that one, but it's one of the big part of the containerization. So long story short, we containerize this application. Version 1 is ready. Now we want to serve this application to our customers. Again, don't forget, we are a small team. So what will we do to serve this application to our customers? Basically, we spin up a virtual machine, because that is what we know. That is what we have been managing during the last 10 years or 20 years, let me say. We have this knowledge in our portfolio. Our other developers know how to manage a virtual machine, how to work with this kind of traditional environment. So for that reason, we spin up a virtual machine, we install Docker, we connect, we SSH to that one, then we type Docker run commands. Docker run for the front end, Docker run for the back end, Docker run for the Redis, and Docker run for the MySQL. So from that moment, it is ready to accept connections from the outside world. So I can put a public IP address to this virtual machine. If it is on premises, I need to find a path for that one, but if it is in the cloud, it automatically has a public IP address. So I can match this with the DNS. So that means that my customers can connect to this website and start buying stuff from my company. So I'm successful. The version 1 is running without any problem. So now the question is, do I need something fancy on that level? Like an orchestrator, like, the things that Clemens told you, like the GitHubs or that kind of stuff. Do I really need anything like that? Of course, I don't need anything like that because we are at the early stage of our development, It's kind of an MVP. So it doesn't make sense for me to spend my time, resources, energy on something fancy just for implementing something, That is more than enough for my current needs. But it will not go like that, as you can imagine, because single machine is not good, even if it is an MVP. So I need to find a solution for the resilience. I need to find a solution for the fault tolerance. What I have done, I have created a second machine, install Ubuntu again. Still, I can manage that one. I know how to SSH a server. I install Docker. Again, I connect to this server, type Docker container run 4 times, and I spin up 4 containers. And in addition to that, to create fault tolerance, I put a load balancer in front of this environment. And now I have highly available architecture for my simple application. Still, the beauty of that one, it is just 2 virtual machines that I know, that I managed during the last 10 years. So I know how it behaves. I know how I can manage that one. But with a simple Nginx server or load balancer service from the cloud, I make this architecture highly available. But it is not painless, let me say. But it is manageable. Don't forget again, we are just a part of a small development team. Just 4 developers is behind that one. They need to manage. So they don't have these operations teams and that kind of other stuff. Time goes, we continue to develop this application, Now I have 4 servers because now the customers are starting to connect this environment, I need to grow, I need to scale. Now I need to manage 4 different virtual machines, roughly 16 different containers. Is it still manageable by my team? I think yes. So, yeah.
Sorry, we have a technical problem. The stream is not seeing your slides, so could you maybe...
I already shared that one, but
present and
then a technical difficulties happen. Sorry for that one. Share my screen.
Perfect.
Can you put this into the stream? Are we good? Yes. Okay. So, long story short, it is still manageable. We started to grow, but I don't need any additional thing to manage the environment. I can still manage this environment by myself. Now, what do you think? Is it still manageable? For this case, I think it's still manageable, but we need some other stuff at this point, For example, at the moment, I have 20 different containers. I need to record the IP address of these 20 different containers to be able to create networking rules and that kind of stuff. So I need to record some information. I need to get something from this environment to be able to manage that one. So maybe I need to write a couple of scripts to be able to spin up these containers automatically. I need to create an Excel file with the IP address and names of the virtual machines and the containers. You understand what I mean, but still manageable. But the question is it manageable? Now I have 20 different virtual machines and roughly 100 containers in my production environment. That is the problem that Kubernetes solves, actually. Because from that moment, if I want to run that number of containers in a production environment, it is not possible to handle this manually. Because I have 20 different virtual machines that I need to patch, I need to monitor, I need to connect, I need to spin up containers, download this container image, purge them in a automated way. So I need to be creating lots of scripts or lots of automation. And as you can imagine, a team of 5 developers, 4 developers, you can't manage that one manually. So you need to find a solution. At this exact moment, you started to need a container orchestration platform because, that is the end story if you try to manage this environment by yourself. But instead of manually managing this whole fleet by connecting them, by SSHing them, what if we found a solution, if we found a new application, new platform, instead of this platform managed on behalf of us to this environment, instead of we connect and say, hey, I want to create this container, I want to download this container, instead of that, if I can create something like, hey, this is my environment, this is my application, these are the dependencies, this application needs to talk with that one, and that needs to talk with that one, number of copies of my application will be that, and after I send this definition to this think this, script this, automation, whatever it is, then it handles our environment on behalf of you. Then you see, I started to get manageability back. So I can now manage this environment because I am not managing this environment. A new child, new foster child in the town start to manage my environment. I just talk with this environment and say that I want this, then it executes. And as you can imagine, this environment is called the Kubernetes, and that is the reason why everybody loves Kubernetes in this community, because it perfectly solves the problems that I explained a few seconds ago. How you deploy this application in that kind of environment. Kubernetes knows this very well. How you can increase, how you can decrease the cost that you need to spend on this environment and increase the utilization. Kubernetes solves this problem very well, and that is the reason why we all love in Kubernetes and why everybody is talking about Kubernetes, because it is designed for that one. This is an article from Google Fellows, Google folks, in 2016, if I am not wrong. And one of the authors is the Brandon Burns. He is one of the three engineers behind the main Kubernetes project. He's now a VP of the Azure at Microsoft. But they have written this article in 2016 to explain why they created Kubernetes, what is Kubernetes, and what is the history of the Kubernetes. And as you can see, this highlighted part, it is the main design goal is to make it easy to deploy and manage complex distributed systems while still benefiting from the improved utilization that containers enable. So basically, the main design goal of the Kubernetes is to handle that kind of problems. When you have hundreds of containers, how you schedule these containers, how you can get better utilization on your field. Because think that I have talked about the Twitter, and probably they have thousands of virtual machines on their environment and thousands of the containers they need to manage, they need to orchestrate, they need to handle. So Kubernetes shines on that kind of environments. Kubernetes shines on that kind of infrastructure, but it is not perfect. The main message that today I am trying to give to you, Kubernetes can solve lots of problems when you have these problems. But if you don't have these problems, in a few seconds, I will show you the bad side of the Kubernetes, because Kubernetes is designed to solve this deployment and management problem of the complex distributed system. For that reason, Kubernetes itself is kind of complex. It is kind of, not easy to manage, not easy to interact, because the main goal of that one, managing this kind of big environments, and it is designed for that one. So I have talked a lot. Any questions so far? The problem definition, or which kind of problems Kubernetes solve? Yes. First of all, let me repeat your question. So what should we expect from the cost perspective from the Kubernetes? A very good question, but unfortunately, like the answer of lots of other questions, the answer is it depends. So I can't give you something like €100 or €200 for that one, but you should know at least two things about the Kubernetes. If you are not using the managed Kubernetes offerings, you should be at least 3 virtual machines for the master nodes and 2 for the system pods. Likely, you should start with 5 virtual machines for the Kubernetes at least, if you are not using the managed environment. Maybe that can be the answer. Yes, Clemens. Okay, sorry. I will give an answer to that one, and unfortunately, the answer is not tied to the money, to the cost. There is another things that we need to consider, and I will come to that one in a few minutes. Yes.
Let's say that in your example, you use Kubernetes from GitHub.
Yeah.
How much will you increase operational cost?
I will come to that one. So exactly, that is the point that I am trying to explain. You know, I am not trying to say, hey, you will not manage Kubernetes, or Kubernetes will solve your problems, or Kubernetes will create more problems. The main thing that I want to say, hey, Kubernetes is good. Kubernetes can solve lots of problems, but in a few seconds I will say, hey, do you know this? There are some drawbacks of the Kubernetes. Are you ready for that one? Do you know this kind of cost, energy, other stuff? So the whole topic is about that one. So give me 2 minutes, you will get your answer. Of course, I am talking theoretically, my friend. Yes, we can discuss with you for hours what is the right architecture for that one, but I am trying to come to a place, you know, I am trying to show you the other stuff that you need to consider, but you are completely right. So actually, that is the thing that I am trying to say. Hey, let's talk about that kind of stuff. So it is not just apples to apples comparison. So there are lots of things that we need to consider, like the things you say also. Maybe it is not easy to manage 2 computers if you don't have these resources. You know, if you don't know how to manage them, if you don't know how to manage an SQL, for example, as you said. So there are lots of variables in this equation, let me say, we need to discuss it, but I'm talking generally, let me say. Any other questions? If not, let me continue with the downside of the Kubernetes, the main topic that I want to discuss. So, yes, Kubernetes is good. As I explained, you can solve lots of problems, especially the utilization problem, deployment problem, scalability problem. But do you know that you should learn lots of stuff about the Kubernetes? You know, Kubernetes is a new word. It has its own terminology. So you should be learning what a pod is, what a sidecar pattern is, what a network policy is, for example. So there are lots of different objects with the Kubernetes. Yes, it is good. It provides health check, scheduling, scaling, service discovery built in. So you can use these primitives, but you should be learning these primitives first. And the second, if you want to get the real benefits of the Kubernetes, what about config maps, crash loop backups, services, RBAC, PWC, PVC, sorry. So what about the storage? What about the network? So, you know, it is not like a traditional thing that we have been managing during the last 20 years. It is not something that you SSH and manage as you know. You should be learning lots of new stuff. And the first question that I want to ask you, do you really have time, energy, and the commitment from your company to get this new knowledge? If not, then maybe Kubernetes is not the right tool or right services for you, because if you don't know that kind of stuff, you can't manage the Kubernetes. If you don't have time to spend on that front, then you will fail. I see several cases, several implementation of the Kubernetes just fail because of this complexity. You know, people need to know, need to learn lots of stuff. First, it is not easy. Second, they don't have time. To be very honest with you, yes, we all talk about these new fancy technologies, but the field is a little bit different. At the beginning, we asked that how many of you are developers, and I saw several hands raised here. Now, let me ask you another question. How many of you doesn't have any tech debt? Nobody. I just asked how many of you doesn't have any tech debt? You see, you are already behind the schedule, so you already need to do lots of stuff. Do you really have time to implement this learning into your workflow, let me say? Remember again, these 5 developers, so can you give this responsibility to them? Do you have time? Do you have resources? So just I'm trying to say, consider that one, because without this learning, without this learning curve, you can't manage Kubernetes. And if you can't manage Kubernetes, then you can't get the benefits of the Kubernetes. So you should be ready to get this kind of information from the Kubernetes community. Second thing that I want to create an awareness or want to warn you about the Kubernetes. Roughly 7 years ago or something, I was managing an Exchange environment. You know, the Microsoft Exchange server, this email server that we are serving to our customers, emails, calendar scheduling. Anyhow, back in the days, I was the main admin, main architect behind a big Exchange server farm. And I remember that our release cycle for the Exchange was 3 years. You know, every 3 years, I get a new Exchange server from Microsoft. So I can roughly implement a new version or a whole new version every 3 years. So now look at the screen. Just every 4 months, Kubernetes is releasing a new version. And it is just supported for 1 year, which means if you are running Kubernetes in production, you need to upgrade your Kubernetes cluster every year. So who will do that? Do you have enough resources to be able to upgrade your Kubernetes cluster at least once every year? Even I'm not talking about these monthly patch releases, so you should be patching these also, but I'm talking about these minor versions. And the bad thing about that one, every new version creates new dependencies, creates new things that you should be knowing. So something is deprecated, they add new functionality. So someone from your team should follow these releases, what is going on. So you should be testing the new releases for your application. So do you have time, resources, energy to follow this kind of stuff? Again, look, if you have this scale, if you have this 20 different virtual machines, if you have this 200 containers, yes, you can do that. Yes, you can find someone to handle that one. So for that, it is worth the effort that you spend on the Kubernetes, because Kubernetes solves lots of problems for you. But do you really have this application that needs to be scalable like we talked with the Kubernetes? Do you really have an environment that you are managing 100 different containers? If yes, then let's not talk about anything, because the Kubernetes is the answer. But if you don't have this kind of big environments that's scalable, that distributed, then consider that one. Do you have resources to learn Kubernetes? Do you have resources to manage Kubernetes? You see, now we have 1.25, then 1.26 released every 4 months, then 1.23 will be out of support. So if your version on production is that one, you should be upgrade this to the newer version. Every year at least you need to do that. Are you ready for that one? Yes. Can you repeat? Sorry.
I would argue the opposite, especially when it comes to API everything. Having a strong cluster really and a lot easier to base off the
But again, at the end of the day, the main thing that I am trying to solve, that is another question, that is another discussion, you know, for the Kubernetes. If I need to build a small Kubernetes dedicated to a team, or a big Kubernetes managed by a central team and divided to the other development teams, that's another discussion point. But the thing that I am trying to say, are you aware of this? You know, every year you should be upgrading your Kubernetes cluster. You should be following this deprecation. You should be knowing this API. My friends, don't understand me wrong. I really like the Kubernetes. I really like to manage that one. It solves lots of my problem, but I have this problem. I want to be sure that if you have this problem also, then okay, let's continue with Kubernetes, but I want you to be sure that you have these problems. If you don't have these problems, please consider that one. It is also not easy to manage Kubernetes, and you should be doing lots of stuff. The last example about the bad sides of the Kubernetes. Are you aware of the day 2 operations of the Kubernetes? Because most of the teams that I encounter, they even don't think about that one. They don't know basically they should be managing this Kubernetes cluster. Who will be monitoring cluster health? who will be managing these admission controllers? Who will be managing this connection between the container registries and your Kubernetes cluster? So Kubernetes solves lots of problems, but it doesn't create the magic, let me say it like that. So you deploy Kubernetes, then it handles everything. It's not working like that. You deploy Kubernetes, you deploy application, then day two operations is on the table. Someone needs to manage this Kubernetes cluster. Someone needs to handle the health of this Kubernetes cluster. If something goes wrong, someone should troubleshoot that one. Do you have any operations teams that you hand over this Kubernetes cluster after you deploy the first version? Do they know how to troubleshoot any problem that occurs on the Kubernetes cluster? Did you give the training to these teams? Are they ready to be able to manage application on running on the Kubernetes? Because if you don't have the Kubernetes, maybe you will use just basic virtual machines, and they already know how to monitor this. They already know how to connect and fix. They already know how to troubleshoot that one. But really, do you have the same knowledge for the Kubernetes on your operations teams? Most of the time, the answer is no. That's the reason why I created this session for my customers and also to present during that kind of event. So long story short, the thing that I am trying to say at the moment, Kubernetes is good, but you should weigh the pros and cons when you come to the decision point. Do I need to use Kubernetes or not? If the problems that Kubernetes is solved, if you really have this kind of things like utilization, scalability problem, need for orchestration, then it's worth to learn the Kubernetes, spend time to manage it, spend time for the day to operations. But if you don't have that kind of utilization problem, because think that I saw lots of applications deployed to Kubernetes, they don't scale. They don't need any scaling. They just have 100 customers connecting them every day between the 9 and 5, and that is all. They don't scale, they don't shrink, they don't extend. So they don't have this scalability problem. Why they are using the Kubernetes? They need to spend lots of time on that kind of stuff. So that is not the right approach, I'm just trying to say. So long story short, if your management cost, learning cost, and complexity is higher than the utilization and scalability and need for orchestration, then maybe Kubernetes is not the right choice for your application. So long story short, I am trying to say Kubernetes is a hammer. If your problem is a nail, yes, it's the perfect tool. It solves lots of problems. But if you want to screw something, the hammer is not the right tool. There are other tools that we can use to build our architectures. We don't need to just follow the hype, and we don't need to just invest lots of time, resources, and that kind of stuff just because of everybody's talking to Kubernetes. That is all what I am trying to say. So, any questions so far? After that, I will continue with the alternative approaches, which other things that you can use instead of the Kubernetes. Yes, come on.
I would argue against it. I would say that you're kind of taking two problems and putting them in one.
Like?
So you're talking about scalability while taking talking about API management. So I would say that this topic that will just scalability while solving any hard problems is happy. And then I'm one with this definitely standardized API.
I am talking about multiple problems, let me say. I'm not trying to combine them, but I am talking about multiple different problems that you can solve with the Kubernetes.
You don't like an argument against Kubernetes would be so if you don't have scalability to things.
Yes.
It still be because there are benefits of having a standardized API to define.
I am exactly talking about that one, my friend. I am saying that if the things that you solve with the Kubernetes, it can be also the single API management. If it overweights the other things, then Kubernetes makes sense. I am not saying that you can't use Kubernetes with the small workloads as well. I am just promoting at the moment the thing that just look to your problem just the things that Kubernetes can solve, and weight it. So if Kubernetes overweight the other stuff, then Kubernetes makes sense. It is not just simple, small, or big, complex or non-complex. It's not easy like that. I'm just trying to create an awareness about, hey, do you know this kind of stuff is coming with the Kubernetes? Don't just start with because everybody uses that one. Also consider this, also plan that one. So as I explained a few slides ago, do you know you should be learning Kubernetes? So it is not easy as just creating the YAML files and deploying that one. There are day 2 operations, there are other things. So do you know this? Do you have enough time to prepare for that kind of stuff? That is all what I am saying. I'm not against that one, let me say. I don't think so. Not always.
Well, so for example, say that you had the latest open SSL that you are going to do that next month. You have the same exploit.
I am not advocating VMs as well.
No, what I mean is that you still have the same security challenge no matter what. So if you're not solving that in Kubernetes, you're probably not solving that in the environment. So why does it matter if you're running a more complex solution?
I am exactly saying that why you are using this complex solution if you don't implement that kind of automatization. So
you're still taking the benefits of the software you still have the same security, so to say. So why not take the benefits of Kubernetes and be exploitable in the whole environment?
my friend, I am saying the same. I am asking this question to you. If this kind of drawbacks overweights the goodies that you can get with the Kubernetes, please use Kubernetes on your production environment. Because of that reason, I started this conversation. Like, I'm not against the Kubernetes. I have built my career with the Kubernetes, but just use it when it really shines. Don't just put you inside a trap. Basically, I'm trying to say this. Yes, Clemens. A little bit loudly, my friend, I can't hear you. Exactly. Now I'm coming to that point. So which alternatives that I can offer for certain use cases instead of using the Kubernetes? So let me continue with that one. The thing that I am trying to say, Kubernetes is not the only environment that you can run your workloads. There are alternative environment and alternative architectures that you can implement for your application. For example, think that you are building a new image resizing servers for your mobile application. Your customers will take a picture from their mobile phone, and you need to implement something like whenever this picture has been taken, it should be shrinked by an application that's stored in a storage, maybe in on-premises or maybe in the cloud. So is it really wise to implement this service, as a container inside the Kubernetes cluster? Or if it is not used heavily, maybe you can create a function as a service type of application, like using the AWS Lambda or the Azure function. So you can create an event-driven architecture instead of containerizing this application. Because for this use case, think that a mobile application, your customers are taking pictures, we are shrinking that one, and it is used just 10 times or 20 times in a day. I don't need to create a whole service for that one that I am running on top of a Kubernetes cluster and manage, monitor, and that kind of stuff. I have lots of fast options in Azure, in AWS, in Google. I'm not talking about the vendor-specific, cloud provider-specific. For this use case, from my point of view, the fast is a better solution than using the container application. Or another example, Again, you are deploying an e-commerce application that as I showed you 10 minutes ago, like the 3-tier application with a simple database, one front end, one back end, one simple cache, and you are just 4 developers that needs to write and also run this application, then I don't recommend you to use the Kubernetes for this infrastructure. Why don't you use the PaaS platforms? You know, because it is managed by the cloud vendors. Again, I'm not talking about just Azure or AWS. Lots of different companies provide PaaS platforms. So you just focus on your code, you upload your code on the framework, and all the underlying hardware, software, platform is managed by cloud vendors. So you don't have resources in your development team to manage that one. So you give this responsibility to another person, another company, another organization, and you can focus on your code. And you don't have the scalability requirements. You know, remember at the beginning, just 10 people, 10 customers are using our application, and maybe for the next 2 years, it will go like that. So it is just a pet project, or it is just a small project. It is not. There's no requirement for the scalability. There's no requirement for the fancy new stuff. Just you need to upload, you need to run your application, and it will be used by 10 or 20 different users. So for that kind of applications, why you should use Kubernetes? I don't see any reason. Just use the PaaS services. Or I see several times on the field, people just create simple application, containerized application. Because this application is containerized, they want to spin up a Kubernetes cluster and run this containerized application on top of the Kubernetes cluster. Do you really need a Kubernetes cluster for this simple application? Or can you use some container platform, container as a service offering from the cloud vendors like, you know, Azure container instances, for example, or Google Cloud Run. So it is a service that you just give your container image name and ID, so it spin up a container from that one. So you don't even need to manage underlying hardware, underlying operating system, underlying Docker. So for that kind of one small containerized application, so you don't need to deploy this directly into the Kubernetes, you can use that kind of alternatives. So long story short, the thing that I am trying to say with this session, Kubernetes is good. On scale, it shines. It solves lots of our problems, but please know that learning curve is really high. You should be managing Kubernetes cluster, and there are day 2 operations that you should be considering for during the long run. If you are ready for that one, if the problems that it solves is bigger than the problems it brings, so I will be very happy if you use the Kubernetes. Otherwise, please consider using the other services provided by cloud providers. And that brings us to the end. Now, I think I have roughly 3 minutes to answer your questions if you will. Yes.
I would like to hear your opinion on one thing, because I think I first considered between your two things.
Yeah.
Because you say, hey, if you use Kubernetes, be aware that there's a super steep learning curve, and it's not just learning Kubernetes, it's also managing Kubernetes,
Exactly.
turning it through all the data working.
Exactly.
Yeah. But what if your team already knows Kubernetes? I think that is a different decision. Because
Exactly.
my team already knows Kubernetes. So for us, it's a different way of thinking about it, even for smaller scale projects. If you already have taken this learning curve, of course, managing a cluster, yes, I can maybe upload it to cloud vendor, but what's your take on this situation?
We were working with the Clemens in the same team before, so now he is working in another team. Think that if we were working again together with Clemens, and if we have other 2 developers, then I don't consider any other platform other than the Kubernetes, because he knows Kubernetes very well, I know Kubernetes very well. So we have already passed this learning curve, you know, so I don't need to consider when I choose this end architecture. So that's the reason why I'm repeating to your question, you know, it is just based on the use cases you need to consider if you have this knowledge. So to be very, very honest with you, why I've created this talk you know, why I'm presenting this code in here and on other several locations, because on the field, that is what I see. You know, I talk with the people for their Kubernetes implementation, but they never consider that kind of stuff. They think that let's start with the Kubernetes and let's put our production environment over there. But do you really know how to manage that one? You know, is it worth learning? You know, you will continue. Will you have the scalability issues? Because I see lots of people just implementing this kind of small applications into the Kubernetes. They think that they should be running their applications on the Kubernetes. That is just because of the containers, you know. I just want to create awareness about that one. Hey, Kubernetes is perfect, but you should know the other stuff like learning curve, data operations, who manage what. If you are ready for that one, why not use Kubernetes? You know, it creates this abstraction, it creates this simple API. It has lots of benefits also. If there's no other question, then it is pizza time, I guess. Am I right?
Thank you. So before you all stand up, maybe 20 seconds to explain you how it works. So we have different kinds of pizzas. We have salami, which is beef, not pork. So anybody not fine with pork can eat the salami. We have prosciutto and fungi. So that's like pork, ham, and mushrooms. We have vegetarian. This is margarita. And we have like different vegetables. So all the vegetarian stuff is in the room. All the stuff with the meat is at the front. All right, enjoy.
Just basically here. 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 Just basically here.
Yes, 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 yes. Okay, and we have to go a little bit. You go there. You go there. You go there. You go there.
Okay.
Okay. Thank you. Thank you. Okay. Thank you very much. Thank you very much. Okay. One more time. And then you are going to perhaps another.
It's the original taste. It's delicious and refreshing.
You use this.
Refreshing. Should be delicious.
You want to change this? 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 Your screen? Your screen? Your screen? Also 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 screen?
Still have that kind of
Screen that I mean. Was it okay? Was it okay? Yes. 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 Was it okay? Yeah. They have seen it online. If you go this, you will cost.
Yeah. We need AI.
Aber können es auch selber machen. Yes. Okay. Thank you very much. Okay. Thank you very much. Okay. Thank you very much. Okay. Thank you very much.
Our live is streaming already, so people can hear what I said.
Machst du die Leute zusammen?
Hey, people.
Kurz mal schreien.
I gotta go to the bathroom now. Sorry for that. No, just kidding. I gotta go to the bathroom now. Sorry for that. No, just kidding. I gotta go to the bathroom now. Sorry for that. Yeah, but that's kidding. I gotta go to the bathroom now. Sorry for that. Yeah, but that's kidding. I gotta go to the bathroom now. Sorry for that. Yeah, but that's kidding. I gotta go to the bathroom. Sorry for that. I gotta go to the bathroom. 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 I go
Okay.
Ich habe keine Ahnung, was das ist.
Muss ich schreien?
Mach das aus.
Muss ich schreien?
Mach das aus.
Komm, ich setze dich rein.
Muss ich schreien?
Mach das aus.
Etwas man sieht.
Muss ich schreien? Okay. So everyone, we are about to get started with our session.
Wir haben two mics hier.
Mach das Rest wieder aus.
One more time, please. One more time, please. Noch 5 Minuten? Noch 5 Minuten? Noch 5 Minuten? Wann wird es jetzt? Ja, Mama. Ja, Mama. Ja, Mama. Ja, Mama. Du hörst hier das Echo.
Ja, aber erst ein bisschen später.
Du hörst hier das Echo, was Mach mal noch.
The microphone is not working.
Hallo Alex. 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 Wer bist du denn?
Hi.
Wer bist du denn? Wer bist du denn? Wer bist du denn? Wer bist du denn?
Du kannst nicht lassen, oder? Kannst nicht lassen, oder? Kannst nicht lassen, oder? Kannst nicht lassen, oder? Aber ich gebe mal, bei mir heißt man gar nicht. Ich vermute mal, eins ist, ich vermute mal, eins. Ja, jetzt sitzen alle komplett. Ja, jetzt sitzen alle komplett. Ja, jetzt sitzen alle komplett. Ja, jetzt sitzen alle komplett.
Okay. So we just start right now. Maybe so we not just everyone right now. Maybe so we just everyone is sitting. But if you want to come, but we still have some space here. So that's Benazir. Let me introduce you to Robin-Manuel and Alexander. And Alexander will give us a talk about GitHub Copilot and the technology under the hood. So come over. We don't see you there.
Thank you.
Right.
You there.
Right. Also slides with our faces. Right. Also slides with our faces. Right. Also slides with our faces. Okay, I myself one or 2 seconds delay. Not sure what my brain can handle that. Not sure what the whole 30 minutes of talk. Maybe we can tell the speaker though. I think. Can you hear me fine in the back rows?
There's no audio.
Maybe we can turn this off. Maybe we can turn this off. I can't even write code by myself. Whatever. Okay, we're gonna try that.
Your last. It's a bit challenging here, but
whatever.
It's okay.
So, the idea is to talk about GitHub Copilot today. And we've seen that there are a bunch of developers in the audience. Who's running their own code by themselves? Quick show of hands. Losers. I don't write my code anymore. I use GitHub Copilot. Just kidding aside, has anyone ever tried GitHub Copilot? That's nice. That's the few. I would say for those in the stream, roughly 25% of the audience already tried GitHub Copilot. I can ask you what you think about it later after the talk. The idea is to give everyone in the audience a feeling what it is, what it does, how we've created it, how it looks like to work with it. Then Alexander is going to show you how it actually works under the hood, behind the curtain. And then we can open up a discussion, because I'm not sure if you've seen that, but Microsoft is currently getting sued over the use of GitHub Copilot and how we created it. And as we have so many developers in the room, I would love to hear your opinion on that. But that's something that we're going to do by the end of this talk. First of all, let's quickly start with what is Copilot and how it works. And for that, I think the easiest thing to do is just go to the Copilot website. And what GitHub says is Copilot is your AI pair programmer. So think of your best buddy sitting next to you while coding. Your buddy knows nothing about coding, but they have seen every open source code out there in the world, and they remember things. So if you start coding, if you start defining functions, if you start importing libraries, whatever, they know, oh, I've seen this before, and they suggest you how the line is going to be finished. So think of autocomplete when typing a text message, but just for your whole code. And it sees what you've written so far, not only in the file that you've currently opened, but also in the other files that are in your project, and tries to guess and assume the right parameters, names, variables. So it's basically autocomplete, not just the current line, but also maybe multiple lines of my code. How does it work? Sorry. How does it work? Yes. How does it work?
It's your system.
So it's my AI with a slight delay, but GitHub Copilot has a delay as well. So how does it work? We basically took Codex, the OpenAI model. It's under PT3. OpenAI has a dedicated model called Codex, made for understanding code. Think of language understanding just for source code. And we've showed all the code that is available out there on GitHub. And with available, I mean all the public code. So basically a model that read through all the code out there, got trained based on that code. Then the code after training goes through the process of cleaning it up. So for example, if someone else checked in the password again, GitHub Copilot is probably not going to suggest you that password. And it's actually never going to suggest you what someone else actually written, only what it learned from it. And it's better in a few languages, it's worse in others, but technically it works in whatever you write. Like technically you can write Markdown with it and write documentation. You can autocomplete code comments. It's very good in Python. It's very good in TypeScript and in Go. But technically, you can also use it for Ruby, .NET, Java, whatever you want. So how it works? So basically, the easiest way to interact with it is writing a code comment. So in this case here, someone wrote the comment: determine whether the sentiments of a text is positive, and use a web service. So this is the information that it gets based on a code comment that someone else wrote, and then it's basically suggesting how the method is going to be autofilled. In a practical example, it looks like this. So if I have GitHub Copilot installed, I have a little Copilot icon down here in the corner. It's going to show me a loading indicator whenever it thinks, but it's always there. So let's say I know nothing about Python, but I want to write a web API. So I'm going to start with creating a file called app.py. And probably somewhere on the internet, I read that Flask is a tool that I can use in Python to create a simple API. So think of, if you are from the Node.js world, think of Express, but for Python. So a comment could be add Flask server. What I'm going to do is it's going to suggest me, all right, for Flask, you probably want to import things like Flask, request, and JSONify from the Flask package. What's I do next? So it's going to suggest me the next comment could be add a Flask server. This is nonsense. So I'm going to say start app, maybe something like that. So okay, app is probably Flask underscore name. Never heard of that. And that's one of the cool things. It's going to suggest me best practices out there. I had a thing in the past where I've created a Node.js app, and I want to define the port. And I said, okay, port in Node.js, if I remember correctly, it's probably port 3000. So I started typing const port equals, and it suggested me 3000 or the environment variable called port. All right, nice. I didn't think of using an environment variable for that, but probably and obviously many people out there who are writing Node.js code in Express.js use that methodology. So why not adapt it and say, yeah, okay, obviously that's the best practice. I'm just gonna use that. Oh, this is on low battery. Okay, my internet is on low battery. But we have 20%. That should be fine. So let's define an array of users. It's called. Oh, it's not called. It's users. Equals. It's an array. And I want to add something. I would say. Yeah, why not? Okay. That was easier than expected. Let's say I have cleaned up a little bit. Someone's name is John. Age is 30. City is New York. All right, whatever. And for the rest, let's say I'm gonna add something to show that it's not just let's say ID is one. Yeah, that's a good idea. So for the next one that's gonna suggest me, it probably knows that I need an ID. All right, because it takes a look at the first user, knows the structure of the first user. It knows, okay, I'm finished now. So let's close that array. And now I gotta tell it, okay, get all users is probably already a good comment, but I can say expose an endpoint called /users and expose all users. Boom, and it's going to suggest me, I gotta probably need app.route /users. The method is a get endpoint because I want to expose something. I want to just get all the users. Obviously, I need to define a method, and it suggests me to return a JSON-ified version of the user's variable. Expose the endpoint. Now we don't need to expose another endpoint, but I can say start the web server. Start the web server. Yeah, maybe. App run true. Okay. I'm just tapping. I'm just auto-completing things. What I can also do, if I don't like the app.run equals or debug equals true thing here, what I can also do, I can hit Control Enter, and it's gonna go through all the suggestions that it's gonna generate for me, and I can even accept a different solution. So maybe I like that solution more because it has the port included into it. So yeah, let's use that one. So it knows, all right, now we have a port. We can start the whole thing. What is it? Python app. .py. It's a good idea. Start the server and I'm port 5000. Fingers crossed. Nothing is found. That's okay because we have the /users endpoint. And here we go. That's our users, right? That's just the idea. I could start with another language. So templates folder, templates, and I'm gonna start with a new file, index.html. I probably want to start with the doc type, and so instead of using that in the body, what I can do is I can add a code comment and say I need a large header. H1. Do I need a form? How's that going to work with the form? A small header. Why not? Small. All right, and back in my app, I can now say, you know what? On the root method here, on the /users, what I have is the JSON array. So I want to expose the index.html file at root level. All right, probably define something that is called route on root level. And maybe it's app.send static HTML file. I'm not sure if that is correct. Is the server still running? Sure. Also sure, yeah. You can. You want me to write a test now, or is the question to ask GitHub Copilot to write a test? Let's find out. I'm gonna ask it. So first of all, color theme, light theme. Thanks for that. You're right. Okay. So here we are. That's not working now.
Still dark.
I don't think so. So let's see what else. Do I get? Okay. Any Python developers here? Anyone knows how to solve that? You think it's no, whatever. I think it was not app.static file. But again, I'm not a Python developer. I don't know what I'm doing here. But you got the idea, right? So technically, it guides you through the process. The question is that someone just asked, can I write a test? I have no idea how to write tests in JSON, but test the/users endpoint if it returns status code 200. And they use it. But I would say it's not too bad. I mean, I probably need a client first. I assume. I have no idea if Python has a client built in. But it's going to use an assert if the status code is 200. And it's also comparing the users to my users array. So it's understood that, okay, you probably want to test users, so why don't you use the users array that you find up front. So the magic is not only that it supports me when I'm exploring a new technology or a new language. It definitely helps me with that. So let's say you need to create something in Go. You have a rough understanding of Go. You're not a pro, but for whatever reason your team decided to go with Go because it might be the correct language for the task. I don't need to remember if assigning a value to a variable in Go is colon equals or just equals, because I get these things with autocomplete, right? So I need to remember less things, and I can especially do less repetitive tasks with it. Because if I say I need a list of 10 users, or if I create a new class and start writing down things, it compares my class to all the other car or vehicle or building classes out there and suggests me things while coding with it and while typing things. So I would say, on personal experience, I've been coding with it for roughly a year now. I don't want to miss it. And I would say it definitely helps more in existing projects where I have more code to share than just this single file here, because it takes a look at the code that I've already written. It tries to adapt to my coding style or the coding style that we have in our team. So it's not just suggesting code blindly, it tries to adapt things. And Alexander is going to explain you now, and me as well, because I have no idea either, why it does that, how that works, and what the technology behind that is actually built with.
Okay. Thank you very much. Okay, take a seat. Welcome to my lecture. As you have seen, I'm Microsoft AI MVP, and also I'm a PhD candidate at KIT. So I have background research, and at KIT I do research on dialogue systems, on NLP systems. How do you to code this, how to get them run, what is the problems on creating NLUI systems, or the natural language user interfaces, and so on. So I think GitHub Copilot is really cool tool if you understand what is behind this. If you have to write this code by yourself, not what Robin-Manuel does, the code for GitHub Copilot to do this tool, I think you have to spend, 1, 2, 3, 4, 5 years, and I think you will be finished.
There are some techniques that GitHub Copilot uses. I want to show you. The first one is on the right side. We are starting from this point. We have been there, Visual Studio Code. I think every one of us have already done this in Visual Studio Code. So only few of you have done this. Okay, who is completely new to transformers, for example? Because that is the no. The architecture, the technology behind the GitHub Copilot, the transformers. Everyone is okay. Some of you okay. I think the problem is on this. You just say to GitHub Copilot what do you want to get, and you get the suggestions. I think the problem is on this point. If you just, this is a small demo that I just want to show you. You just write a comment, not only one kind of sentence. You write the whole example from the researcher that I am. You write several sentences, and then you get the whole bunch of code there. Just imagine how does it work. If you have no idea behind, Torsten and Martina, who host this event, they asked me not to do a lot of scientific stuff. So I try to get general, really like, not really a lecture on AI here. So just imagine, and also I'm getting this from books that you can also read it if you are interested in this. We are talking about sequence-to-sequence architecture. So we take one sentence from Robin-Manuel, from what you have asked. You want to test something. You write a test. This sentence will be generated, so some account calculations will be done, and then you get an answer. How does it work? That is called encoder-decoder architecture behind there, and you can also see that we are working on sentence and creating new sentences after we get some input from a user. On the encoder part, we get the input, and it's somehow, I will explain it later, goes through the all of cells, and then we get one state, and this goes to the decoder, and decoder decodes this. That's okay. The output from the encoder is a hidden state, is a vector. That is something that is mathematical. That's something that you just imagine. I want to say transformer are great, for example, and I want to translate it into German. So transformers in großartig is a German translation of this. I hope it's okay for all of us to understand this. Also, the translation part. How does it get? Okay, I have to just sequence to sequence goes there and calculates a value for the word transformer. Then passes that to the next state to calculate the vector with the word R. Then another one, great. Then it passes to the decoder. The decoder transforms this back, so it decodes this state back. It's just a vector, so mathematical, it's a vector, it's just some numbers, and then represent the idea behind what is on the left and what we want on the right. So without anything mathematical insights here, I just want to let you know, because RNNs, it's already old architecture that's already been there, and now we are talking about transformers and also GPT-3 transformers and so on. And why now and not earlier? Because we have something that is new, that was introduced, unfortunately, in 2017 by Google, not by Microsoft. It's a paper, attention is all you need. Perhaps you know this. If you are interested, just read it there. And we are talking about attention. So in this kind of translation, we get some states or more states of our version. We have also a problem of RNNs, because on the last state that we pass to decoder, that is only you see this information bottleneck there. I hope you can read it from behind. Because the last state represents only the meaning for the whole sentence, and decoder in the first state gets all of this vector. That is a problem of RNNs or also LSTMs. They have short window. If you talk about transformer and they have this attention mechanism and we get all the states, we can create endless text because our attention mechanism, you will see it in the future in a few moments. It looks at the words that we need, that we refer in the sentence. So that is not the big problem for us to create endless text, for example, like poems or something like this. So this is the encoder-decoder architecture that is there, and we have just to get there one sentence inside and we get some output outside. But it is basic. If you get your sentence and you say, okay, we want to write some test there, I don't think we get in this kind of architecture the right answer for code or right suggestion for code. Transformer, as I said, attention is all you need. It's a neural network architecture proposed by Google, and it's excellent on capturing patterns in long sentences. As you have seen there in this demo, this is our input, and the next word refers to planet. Began to colonize. Okay, we reference to planet, Earth, air, and so on. And you see that it's not even how NLP worked earlier. We had 3 words, and then our language model. I will explain it later. What is behind this? Our language models just see, okay, I have 3 words. Now, what is the next one? What is the next one? What is the next one? Because I get only this few kind of information, I can only just imagine earlier this kind of coding wouldn't work. This is one screenshot from the paper, and forget the whole of ads, norm, calculation, and so on. The idea behind this is that the input that you get for encoder, it also goes to the decoder, and you see it here in an action of this kind. You see that the starting to decode this, you see it's on the bottom here. I hope you can see it. And the question for this is, hi, how are you? And if we start to decode this, the answer is, I am fine. And how do we get this? Our decoder sees not only the starting point and not only the vector from the last position that was by RNN. The decoder sees the old state and can also refer to the whole bunch of information that have been in the history for the last, 10 years, if I would work with Copilot so long. So that is the problem. I think that's the old architecture had, and this is the better architecture with transformers, that we have attentions that can easily go through the text and search for the input that they want to refer. This is kind of slide window that we have with RNNs. If you use, you can see, you can go further because there's a lot of information there. RNNs are really short. LSTMs, it's newer as RNNs. They have bigger window, and this transformer we can go. However, we will talk about Azure and container and so on, power. Whatever power you have, whatever compute power you have, you can go there and then create whatever you want with transformers. So on the other side, this was only the suggestion side, GitHub Copilot. If you go to OpenAI Codex model, and as Robin-Manuel already said, it has been created on public code and text from the internet and so on. How could you generate now some code with GitHub Copilot? If you want to train your model, you get your answer, you get your data. What does it mean? Perhaps if you are familiar with computer vision, Cats is the best example. You get some pictures from cats, and that is your data. Yeah? If your computer doesn't know what is a cat, if you label this picture with a label, this is a cat, then you have data and you have your answers. Then you train your model, and your model understands after training. Forget what is training. That's just a calculation. So your computer learns what is a color, what is an eye, and so on. So it can understand after you provide this information, and you get your new data, perhaps what is the prediction, or in our case, what is the code suggestion for something that I have seen, so anything new, what I have never seen before. Okay, if it's really, for example, I get data is 100 cat photos, answers, I label them as a cats, as a dogs, as whatever I want. And after this, I get my model. So in this moment, we are prepared to start to work on new information. Why does it also work? Because GitHub Copilot, they have done also transfer learning. Perhaps you have heard of it. You train your model, and then you adapt this model to a new task and predict also something new that what your model have never seen. That is called transfer learning. So your model is trained on something, and then you adapt this perhaps to a new corpus or language corpus in this kind, and then you are also able after this to get new data, and also in production to predict what is new input compared to your model, what is inside there, and what can you do. So programmer writes a comment, just Robin-Manuel did. The coding process is just they breaking the problem, the complex problem, in some simpler problems, so just even simpler, easy tasks, and then mapping these simple problems for something that is already exists in language model. Perhaps there are libraries, perhaps APIs, perhaps functions, and so on. So that is how it does work. The use cases on NLP, we have a lot of use cases for natural language processing. If you go to the core task, the first one is, for example, if you get one answer or you get one input, this is one sentence. You want to do perhaps text classification or information extraction. So you get some information from this text. Also question answering or chatbot and so on. So conversational agents, that is my PhD topic, but that is more complex. In this case, it's just for NLP side. General, okay, spam classification and so on. There are a lot of stuff they can do with NLP. What they can do with GitHub Copilot. So some use cases, for example, comments to code. You have seen already this. I think that's a really cool example. We can autofill. So, for example, we get, that you already said, we get some pattern, and then we see in the next step, this pattern is matched. Cool. Okay, I can go further. You can run tests. Thanks for the question. And also, you can get here and create app. Very simple, perhaps, but you also create this app. I just take here some demo that is 8 minutes long. Sorry for that. But perhaps I just say to you what is difficult and perhaps what is not difficult, what is easy. Perhaps if you say, add this image. Is there, and okay, then you can be small, a little bit smaller from this point. Okay, that's just CSS there, so you can just go and crop this and so on. The cool stuff will come in a few moments. when you go there and say, please move it, for example. So this one is just only, okay, I want to get this virtual central and put it on the left side. That's already also just say that code. That's nothing more, I think. That's pretty easy, but now I want to animate this rocket ship horizontally, bouncing off the right and left walls. So now we get some functions. We get directions, we get speed, they get also bounce from the walls. You have dimension. I don't think that is too difficult to write this code, but I just want you to show how does it get and get more complicated for this. Disable, okay, if I want to disable something that is not so, it's not so difficult. Now, okay, say background and so on. And after a while, also if you want to see the whole demo, after a while, there's a stone there, there's a collision, there's collision. You can get there and build something more specific. So for example, if I click on this rocket, then say me firing thrusters and perhaps also temporarily speed up and so on. So just imagine this is just written with help of our language model. We did nothing else. I think it's really impressive because for this demo, if I would do this in my PhD, I would say spend 1 to 3 months for just coding only for this. It's really easy to understand, but if you want a program, go just compare to this. What do you see? This program should do it for you and should understand your instructions. That's really impressive because you have to do a lot of NLP stuff. You go NLU stuff, so your context is there, your intents, so your topics should be understood correctly. Then you have, okay, there's no dialogue management. This was my topic of PhD. That's just I got input and got instruction there, so I get input output. Dialog systems is not there, but there's NLG, so we got the generation, so natural language generation is on this side, and that generates code. So and then I would also animate the asteroid, and I think in this small demo, you can see already some really difficult stuff that should be difficult from, not from coding here, from the right side, difficult from understanding from the natural language to code. So this step is really just to go there and say, what is exactly it's talking about? What is the context of this? Because you have to parse all of these sentences because the machine, the computer is stupid. The computer understands only 0 and 1. And you have to teach the computer to learn this. Also, as a GitHub Copilot also learns a lot because the GitHub Copilot also learns your patterns, how you also code there and so on. Okay, now you see we are going some collisions and so on, and after a while I can see, okay, make it score visible and so on. So that's it. I think for this demo it's okay. So my part is over. Extension, that's your part. Thank you very much.
I'm not sure if I understood anything.
I'm sorry for that.
But I gotta trust you with my life with it. If you need help with your PhD, though, let me know. All right. So, but I think the interesting part of it is we've seen it, how it works. Let's be creative and let's think what can be the future, like what's the direction where this can go, because I think it's not just code completion. It's as Alexander said, it's also telling the computer what I'm expecting from it. So let's say, and we already had demos, let's say it's not just code. Let's say we have something like a Copilot integrated in Excel, in Word, where I want to style certain things, in 3D applications, where maybe designing a 3D world, and I say, please make all the trees a little bit greener, and please add some snow to the bottom. Or think of, maybe I'm not typing, maybe I'm just talking to my computer while I'm coding. So let's say I'm extending my current work with mouse and keyboard, also with my voice. And then maybe I have another input mechanism and layer to be a lot more productive, to have less repetitive work. So I think that's where it becomes interesting what the future brings and how the future developer workspace might look like. Another super nice example is of where GitHub Copilot is going is an extension that we have in Visual Studio that is called Copilot Labs. So that's what the GitHub team is currently experimenting with. And one super cool feature here is the explain functionality. So let's say you have a junior developer joining your team, or someone who's never seen your code before, or someone who's just about to learn the language. And they are discovering your code, either by doing a pull request review, or by just searching through a certain line where a bug might have hidden. And you want to say, hey, dear Copilot, please try to understand what I'm seeing, and please help me understanding it. So that's a method in C# here. That's one of my home languages. So that's actually a method that I wrote. It's trying to get a JWT token. So there is a JWT stored somewhere. I want to check if it's still valid. I have a 30-second tolerance. So if it's only valid until right now, I still want to renew the token because probably next second it's invalid. And if it's valid, I just gotta return the token. If it's not valid, I gotta acquire a new token and then save that token locally. What I can do, I can highlight and mark. Oops, what I want to have explained. So let's highlight the whole function here, and say, hey GitHub, explain me that code. So I can ask Copilot for an explanation. Do we still have internet? We do. All right. So let's try again. Not sure how the connection is. That's very true. That wouldn't be as impressive anymore after I explained it already. But you get an A for effort. So let's ask it again. Otherwise, I need to probably restart the thing. So disclaimer: everything I show you is preview, beta, stuff like that. That's why they call it Copilot Labs. Probably just going to do it again. So let's just restart VS Code. That's that one. Let's restart VS Code. Glitch in the matrix. So I got to mark the whole method again that I want to explain. So maybe someone just joined the team, never worked with OAuth, they don't know what I'm doing here. Ask Copilot. Yeah, that's what I did. Does it make sense? Please explain me that. It worked in the train on the way to Yeah, probably. Oh yeah, but that's just the C# extension. Dude. What do you think? How I know what the code is doing? I just asked it. You don't understand your own code anymore. That's correct. Yeah. So that's not very impressive. So maybe code does the following is another method that we can try. For some reason. Maybe they don't use Kubernetes. Yeah, okay, it doesn't work. Too bad. Maybe next time. Okay, let's use other things. So what they're also trying to achieve is language translation. Let's say you already have written a bunch of code in a certain language, and now someone else needs that code, but they don't need it in .NET, they need it in Python. Doesn't work either. Oh. Am I connected? I'm not allowed to use Google. Yeah. All right, I'm not connected. That explains a lot. The thing is, if I disconnect from here, am I back? Is it just that slow? The thing is, if I disconnect from here, is it just that slow? The thing is, if I disconnect from here, I mean, it should be good enough, right? I mean, okay, let's give it another try. It should be good enough, right? Let's try again. Okay, let's give it another try. So let's retry Copilot. So let's retry Copilot.
Sorry, I talked too long.
Let's bring this code. Like one more try. Otherwise, I just gonna explain. Like one more try. You should be seeing, and then you need to trust me. You should be seeing, and then you need to trust me. You should be seeing. So let's wait until the whole thing starts up. That's what I just said. Copilot only works if it's there. And it's a good demonstration that this thing is not working locally, right? So it sends your code to the GitHub servers. That's something that you need to know. That looks a lot better. So you're gonna mark the whole method again. You forgot everything that you saw. I want to explain. All right. Explain the code. It's down again. Maybe explaining breaks it. All right. What I saw in the train is that it actually explains. Okay, so think of you have working internet. Someone new is joining your team. They have working internet connection as well. Then maybe they can use that once it's out of preview to explain code to you or to translate code into a different language. And actually, what I find super interesting is make code more readable or clean it up. Like making it more readable should, if it works, add more comments or try to find things where I can maybe simplify an if-else statement, something like that. I can also try to fix a bug. And I would have loved to show you fixing the bug, but is it? But is it the connection? Actually, no. Is GitHub available? At least they say it's working. Copilot is not normal. Okay, whatever. That would be too easy. Could not connect. That's right. The API or GitHub. If there is anything on root,
Your fault, not your fault.
Live demos. Yeah, but someone has an idea. It's working on your machine? Are you kidding me? Yeah, I can try. Do you think it's my Wi-Fi? So it can forget.
Really?
But what's the password? All right. Is api.github.com working for you? Oh,
okay.
All right. It was my Wi-Fi.
Finally.
So let's give it one more try. Explain the code. Here we go. It's not me. So it says, here's an explanation of what the code does. Check if the last token is valid. If it is, turn it. If not, create a new token request, send it to the request server, deserialize the response, save the token and time when it was issued. It actually gives me that as a comment. So I can just take it and put it in here. Say, hey, this code Oh, look at that. We should do that more.
Okay.
All right. Then we can also use the language translation. So say this thing is nice. How does it look like in Python? A lot more spaces. I think it's just a tab. Boom. So what it does is it adds some comments, right? It says create HTTP request, send the HTTP request, deserialize it, save the token. So if I undo it, there's a lot less comments. We can also introduce a button. So we can say, let's make that. All right. So very nasty button. Usually it's hard to find something like that. Let's mark the whole method again. So we see this is the bug, right? This is the bug, right? Fix the bug. Do like this.
Explanation first.
All right, but you got the idea, right? So you clean things. So the moment it understands our code, make it more robust. Maybe adding a few try catch cases. What did it do? Oh, and checking the response code now. So I never checked if my response code on the server is active. Assuming, yeah, they're just going to have whatever content and now it's going to check. Okay, let's make it more. Even if it's not working, even if it's not working, very good at writing, let's think about the future developer workplace or workflow, where I have something sitting in my browser that actually understands my code, tries to, helps me with all these little things, with explaining things, with giving me hints if it actually sees me writing a bug. Hey, why don't you put that in the transaction? Or hey, why don't you add a code console? Or why don't you use that code and put it in a dedicated method to make it more readable? Stuff like that. And also not just suggesting it, but also just do it. Make it easier, make it right. I think that is a very good direction where this is going. I'm not going to say that. What's next? One last thing I want to have your opinion. And that's something where I'm personally not going to share my opinion there. Before I share mine, I want to hear yours. But I'm not sure if I'm right. So I think we can all agree that the technology itself So what GitHub did is it took all the public code out there and let their model train based on all the available code, all the public code, regardless. And it's not only also licenses that technically say, hey, we're not going to use my code in our project, you need to make it open source. It's also licenses that say, hey, you are not allowed to use my code license from you. It's also licenses that say you can use that code wherever you want. Please attribute me as well. And they don't because GitHub, because our mentioned way, we don't use your code in our product. And by the way, GitHub Copilot is not open source, and GitHub Copilot is not free. So it's definitely a commercial closed source project. But what they say, basically, your code is open and reusable. So you need to prepare that someone or something reads it and learns from it. So just the same way as we all learn on GitHub, on whatever. So I read and learn from it, and then reuse that learning in my own project. The author probably 1 month, or if they mind it's maybe not just a big deal because they put their code online, knowing that's knowing. But now that product with that code, we have to discuss learning. Only the learnings that come out can come quite close to it. But there's some repository authors out there who don't consider it fair usage of open source, and I can understand that. And others are actually super for acting against the license. And I would be super interested in what you were saying on that. Currently, the lawsuits and are basically going to decide if the authors are right or not. Does anyone want to share? And you consider it as an okay usage of open code because it's not closed code, right? It's not private repositories. We only talk about public repositories where the authors know that someone or something is going to read your code.
And Copilot does not use the code explicitly, just use the combination of
just the learning.
So just in a way some information in the code, not the code itself.
Interesting. Thank you. Someone has a different opinion on that.
Yeah. So what I doubt here is the closeness of the code that Copilot produces in comparison to the source it got that sample from. So I think there is probably like a very good match between the source and the output Copilot is producing. In that case, it's like I've also come across extractive and abstractive summarization, and we do not have really good abstractive summarization yet. Most of the summarization that we do today in NLP is extractive. So I believe that Copilot is also doing that, close to that maybe, and therefore if it is copying pieces of code from open source, then it should kind of some credit.
There was another audience comment saying that NLP basically isn't that far today, so they can fully generate newly created code pieces from it, and that the generated code might come super close to the initial training set, and that is basically copying the code. You might be calling it differently. Okay, interesting opinion. I think I hear that, yeah.
from a legal perspective, I would expect, or from a moral perspective, I would say it's okay and it's fair use kind of. However, I would fear that this discourages some people from actually open sourcing some software. So I think it would be wise, for example, in this case, GitHub, to stick to the wishes of the people who open source their code in order not to discourage others to open source projects, because they say we do not want to have models trained on our work and code.
What do you think about an explicit opting out option, so that I can opt out of being scanned by GitHub Copilot whenever I publish a repository? Would that be something that gets a consensus in the audience? Do you
I think from knowing like how the German law usually works, you need to opt in such a situation.
Good thing GitHub is not a German entity.
Just like teachers, like seriously, you need to opt in. Maybe in different countries you can opt out.
But aren't you implicitly opting in when...
should repeat the comments. Both.
Thank you, yeah. There was one comment saying, from a legal and moral perspective, it's probably fine, but it might discourage people to publish open source code. And I was suggesting maybe an opt-out option, where someone else from the audience basically said that probably opting in, especially in Germany from a legal standpoint, might be the better option. And the thought that I'm just having is, isn't publishing your source code online kind of an opting in into that this source code is probably being read?
But on that point, I'd say it's a whole other level if there's just one guy searching for some solution on himself, opposite to having a trained model proposing
your code to thousands of users.
Yourself,
I got that.
to thousands of users, and also having scanned thousands of repositories.
Okay.
That's a whole other level.
Yeah, I
because
understand
of
that.
I think this opting in or out thing would be a really good idea, because I don't think anyone who put some code publicly on GitHub, I don't know how long it existed, years ago, I don't think he thought about there's going to be a Copilot scanning my code. And
I hear that argument quite often.
That everybody does that easy.
There was the comment from the audience saying, yes, if someone open sources code, it's probably, they know that it's going to be read, but by a human once to learn from it, not being scanned by a bot, and then that their code is going to be suggested to thousands of different users. And that's a comment that I actually hear quite often. That's exactly the point where I'm not really sure how I'm thinking about it. One side of me thinks that, all right, everyone, or like everything you put online on the internet will be scanned by some sort of bot at one point in time. But I feel that you say, but the intent is a different one. I'm open sourcing it for the intent of maybe helping an individual developer, or maybe gaining confidence in the code that I wrote for other large companies to actually use it. Not that someone else is taking it, but yeah, it's different to have these, like, is the intent saving you from someone else doing something with it? Like if I draw a picture and put it online with a do what the fuck you want license, and I don't want corporates to use it, is it saving me from it? Probably not, but I get your point. And from a moral standpoint, I'm probably on the side. Yeah. Sorry for the people in the back. I'm not seeing you probably. I'm seeing that you're raising hands. I'm not sure how much time we actually have left, but we can definitely have this discussion afterwards in the back, because I definitely need another side of pizza that's still there. But we can have a discussion later. But first of all, you. Thank you.
So yeah, by the plugin, if you like put the code out there for someone to learn, basically what Copilot does is allowing you to learn from that code, but it's kind of search engine of steroids, because what you do usually you kind of search for code for example, you discover some GitHub and you learn from there. What Copilot does for you, it kind of absorbs everything and then spits out the best search results, maybe a little bit transformed. So in this sense, Copilot can.
Interesting comment, because like for folks online, what someone from the audience said is basically Copilot is just a search engine on steroids. What I think is interesting about it is if we see Copilot as a search engine, it's quite similar to what Google does. And Google is also crawling your website if you want it or not. And yeah, it's probably suggesting their users content from it.
But if there's a marketing that is different than the Google, for example, if I want to get this data, GitHub will provide this data to me or not? Will GitHub throttle my request to get the same benefits they have or not? That will be the thing. Think that I'm another company, I want to build the same Copilot, and I want to save my model on the GitHub.
Right.
So this
interesting. Yeah. It's interesting. Basically, like, is GitHub using its own power to be the only ones who can ever provide such a model because they restrict others on
I
having
think that's all the problems because it's public. Everybody can access even GitHub or the other.
Right.
They can build this.
But they're not going to let me
Actually,
crawl
they
GitHub.
and they let at the moment. You know, you can get the public repositories from the GitHub, but only care. I'm not sure if they will throttle or not.
I'm pretty sure they
probably
they will throttle you. Yeah. So I promised someone from the back. So yeah.
So ignoring all the moral arguments, let's draw parallels that say, well, all books are published out there. So I build an AI that reads books. And I write a book about a German boy called Popup who grew up in the basement and was a wizard. So the question is like, in that sense, well, books are published, I'm reading it, I'm learning something, and then I write my own book. Obviously, lawyers are going to go after me because I'm writing a book that's too similar to something else.
Yeah. I think that's a very wise comment. Someone from the audience said it's actually similar to just letting an AI read all the books that are published out there, and then suggesting me as a new author a book that is super similar to something that already exists. Obviously, the lawyers would go after me, and yeah, of course. I need someone from the back as well. So you are the furthest in the back. So it's you.
Yeah. So if you use open source code in a closed source project,
yeah,
and you get money from it, how does that work?
Depends on the license.
Yeah.
All right. The question is: are they using your code, or are they using the learnings from your code? I think that's where, like, that's the point we need to narrow down, right? Is it actually your code, even if it comes super close to it? Then probably yes. If it comes super close to my code, if it's just a different formatting, then it's still my code. But is it my code because it's like?
And how would you protect yourself against sabotage, right? Like, if you would have malicious code by someone.
Also an interesting question, yeah. So I wouldn't 100% trust what GitHub is suggesting me because it might be malicious code, yeah. Sorry, that's probably the last question that I can take because we are already over time. But I think it's okay. It's okay? All right, then we're going to continue that. but save me at least one slice of pizza, please.
Some software licenses say that the derivative works needs to be licensed under the same work, and now the question is the trained model a derivative work of the source code?
That's exactly the question, yeah. So the question is, the comment from the audience, just for the people in the chat, was there are licenses that say if you derive from my work, you have to republish it or buy a license from me or whatever. And what we actually need to discuss, or what we need to find out is generating a new model from the learnings, is that deriving from your work? And I would say, from a legal perspective, probably it is, yeah. Because I'm not using your work, but I'm deriving from it. So I used what you created in the past to create my product. My product would not have been created without your prior work. If you see it that way, then it is using your code, yeah. Okay.
Yeah. Only if you have gathered enough of opinions about this topic. I actually had a couple of questions about Copilot and presentation itself.
Okay.
Maybe you can continue. And
probably. So we're gonna finish the moral round, and if we have time left, otherwise I'm gonna be here the whole evening.
I have a kind of a counter question. So why don't you or Copilot release the generated code, not just under appropriate license?
That's a very good question.
I mean, that would more or less solve all those discussions.
A question from the audience is like, why don't GitHub or Microsoft or whoever, why don't they just publish the derived code or the the trained model or the learnings to the public because they use it from the public. Wouldn't that be fair? Yeah, like a fair use? And then, yeah, I mean, personally, I also think it might be a good idea to probably say, hey, this is open source. If you just want to use it in a very convenient way, we're going to host it for you. You can integrate it into your favorite editor, and that's something that you can still pay for. But if you're fancy and throwing, and yeah, maybe wrap a Docker container around it and throw it somewhere in the cloud, and if you want to run it yourself, please do. Yeah, I think that would be a super fair usage. Yeah. Sorry.
Yeah, I also think you should do it in an offer to like commercial way as well, because I think like if you have a big vision for the Copilot, then I mean it can plan software development massively, and I guess that's also the spirit of open source, that you offer something and you expect that even something bigger is coming out of it. So I think, yeah, Microsoft wanting to make money with it, I guess that's bit more of a question.
That's already an A. Yeah, very interesting thought from the audience was just about actually if we are pursuing a bigger purpose, and if all the things that we're showing here with the GitHub Copilot Labs, if that is our intention to transform the developer workspace of the future, then to prove it, we should probably open source it or find at least some way of also offering a non-commercial model there. Yeah, especially after taking it from you. Okay, yeah, makes sense.
That first my idea, first of all, probably we can ask Copilot what to do. Yeah. And it suggests right things. What do you ask?
Write your own source code.
Now create the MD, create the markdown file, then it.
Oh,
I like
that. That is also
Oh, that.
Ouch!
all right. Wow. That's boring. Why is GitHub Copilot not public or not free? That's your answer. Oh yeah, true.
The second point was about search engines have top results, top suggestions. And from these suggestions, you can learn, you can know something new. And probably Copilot can provide some top results, top popular results, where people can learn something new. And it's, or Copilot should generate more code than people. Something.
So the comment was, if we see Copilot as a search engine, then why don't we have something like top posts where people can learn from, or maybe an engine like Stack Overflow where can accept the right answer and so forth. So it kind of tries that by if I say, let's say install Express.js. Right, so what I can do is I can hit Command Enter, and it's gonna generate different solutions for me. So kind of a certain, and it's ranking them by what it thinks is my most likely answer to be accepted, and it also learns from it, so it kind of goes in that direction. Yeah, that's not really what you mean. I get that. Yeah. Right. Question back.
I think one problem, or the real problem with it, is that it's super easy to write a search query that fits a specific algorithm that someone wrote under copyleft license, for example. So you can easily find that, like there's examples of like matrix transformation algorithms that are super optimized, that are really reproduced like line by line, 25 lines, 13 lines, small code sample that is very specific use case. You can write with one line of a comment, you kind of copy that code over to your library. And then you copy it over because the model is trained on it and it knows it by memory, let's say, but still it's the same source code. So and then I think that's, but maybe the solution would be to like do a reverse search. Where is the source coming from? Where's this idea coming from? And then bringing also in the information, like so that you can make an informed choice. Is this a copyleft license code? Maybe you use the library and you contribute to something like that. So
interesting thought from the audience here. Like someone said, what if we like, because obviously we can use GitHub Action as a reverse search engine. So if I would challenge it to suggest me a very, very certain or very, very specific piece of code, I could probably write a comment that only matches to that specific code, right? And the other comment was, if we come to a point where the synthesized solutions that GitHub Copilot is suggesting me is so close to one individual solution, wouldn't it be nice if in that case, we're just going to have a hint somewhere, have a link to the GitHub repository, name the author, stuff like that. So the moment where it comes super close to one individual specific work, that probably should be the moment where we're going to attribute the author. Whereas if you're just using it to autocomplete a single line, or just using it to make your work a little bit easier, then it's probably so generic that it can't be narrowed down. So yeah, I think that's a very good suggestion. Maybe somewhere in between how narrowed down a suggestion is and how close it comes to an actual work of an individual. Maybe there needs to be a certain threshold from when on we can say, okay, this solution is probably coming from the training of that specific repository. Let's name that repository. I like that.
I think we
last comment. Last comment. Thank you. First of all, thank you very much for that super open and fruitful discussion. I love it. I love it. Yeah.
We are always using it, going finding something that we were used to for it. So now that GitHub started making money out of those, they did obviously an amazing job to come up with the whole thing. So it's also starting to have some profit sharing model. Whatever code is suggested thousands of time, and we have a lot of money selling licenses which is showing that code. I should be able to also hear some part of it.
Yeah, nice suggestion here from the audience. Someone said, okay, if my code is actually being suggested or something that is learned from my code is being suggested as quite often to the users, why don't they give me a share of their earnings, because they basically make money with my code, so why don't they, give me something back? I'm not sure how easy it is for them to narrow down where exactly your learning came from.
It's not easy. It's impossible. It's impossible.
The expert says it's nearly impossible, and that probably makes it so hard. But I like the idea of giving something back, or at least if I'm trained on the millions of lines of your code, maybe then I'm gonna give you something back, or you get something, or you get, or maybe then you can use it for free, or whatever. But I like the suggestion and where it's coming from. I still think, and the expert says it as well, it's quite hard to narrow it down. So thank you very much for that discussion. I hope you are fun with it. All right. I just want to encourage you to just give it a try. I think there's a free 30-day whatever trial, so that you can actually experience how you would actually work with it. Because what I showed is not very very much realistic because you won't start with an empty file, but working with it in your project gives you a feeling on how it actually suggests.
So, guys, just before I leave, just one thing. In theory, there would be a fourth session, yeah? But you realize by now that we are running out of time and we have planned to end at 8:30. I think I can put the microphone back. Unfortunately, Janek, who is also the organizer of the Azure Meetup Berlin, cannot be here today for unforeseen reasons. But I think we spend the time pretty good.
Vielen Dank. Du auch, danke dir.
I just want to tell you two more things, or we want to tell you two more things. So the upcoming events will be, the first one will be on
December 15th is the next one here. That's organized by us. There will be the other one at December 8th, organized by the community Kubernetes and Kubernetes meetup. And then the other one we are doing is also on January 19th.
Exactly. Just gonna put it back here.
Now let's see if it's working. Yeah, this works.
Hello?
Yeah, I think now I've yelled enough, so it's okay.
Hello? Hello? Yes. It's loud enough, no?
Where is the image on the meetup?
I did turn this on.
It is selfie time.